Hello everyone! We're super excited for this course, and hopefully you're watching this video because you know what DevOps is, or you are interested in becoming a Linux sysadmin, or you just want to learn Linux. In order for us to really succeed throughout the course, I want to show you what the course is going to look like for you, where we're going to start and where we're going to end up, so that you have an idea of the path you're going to take, all the things you're going to learn, and why you're going to be able to call yourself a Linux sysadmin or system administrator or a Linux system engineer by the end of this course. So where does it all start? First thing we're going to do is set up your environment. This course is going to work no matter what system you have on your computer. We're going to talk about Linux distributions. We're going to install Ubuntu on a virtual machine so that you're set up for the rest of the course. From there, we dive into the Linux fundamentals. These are just the things you need to know to get us started. We're going to talk about things like terminals, consoles, shells. We're going to talk about the Linux command structure, all the basic building blocks for us to succeed for the rest of the course. Now, starting in this section, we're going to introduce what we call challenges and quizzes for you to actually practice what you learn. This course is very unique in that once you learn a section, we actually have quizzes and challenges for you to do with solutions so that you can actually know that, hey, I didn't just watch a bunch of videos, I actually watched, learned, and then practiced these things, which is, I think, a great way for us to learn and hold on to this knowledge for many years to come. Once we have the fundamentals down, we're going to talk about the Linux file system, which is extremely important. We're going to talk about user account management. We're going to talk about file permissions to make sure that, well, we give the proper access rights on the computer system, one of the most important parts of being a Linux sysadmin. We then get into a really exciting topic of the Linux process management. We're going to talk about this idea of processes and the Linux security model. We're going to talk about signals and killing processes, background processes, and job control. From there, we dive into the exciting topic of networking. We're going to talk about things like getting information about your network, setting up static IP, checking for listening ports, using tools like Netstat, Telnet, Nmap, copying files over the network with things like rsync. We then dive into software management. How do you manage software and different packages on a Linux system? We're going to talk about compiling programs from source code versus package managers, compiling C programs, using APT. Again, if all these things sound intimidating, don't worry. We really teach all of these things from scratch so that it all makes sense to you by the end of it. We then dive into system administration. This is where we talk about things like task automation, scheduling, using cron jobs, getting system hardware information. We then get into bash shell scripting. This is where we learn about running scripts, learning some basic programming so that we can perform different tasks on a computer using the bash shell. Once we've learned all of this, we get into the exciting topic of Docker. This is where we do our first big project, and that is running a containerized application with Docker. We're going to have an overview of Docker, what it is, why we use it, what are containers, why do we need them, how we push custom images to something like Docker Hub, and how it all fits in with what we've learned up until now. Once we do that, we then talk about Linux security, specifically how to secure and harden a Linux system. So all the best practices and what to do when we have this Linux system that we've put somewhere online where others can have access to it, but we want to make sure that, well, whatever access we give is limited to whatever we want. We have another project coming up after that where we talk about setting up a web and a DNS server. Again, I know we cover a lot, but we have things like how to use the HT access file, how to install and secure a MySQL server. We even talk about things like PHP MyAdmin, installing a web application like WordPress. And as if this wasn't enough, we still have a few more sections. Next one is talking about Ansible. So this is where we start automating Linux administrative tasks with a very useful tool called Ansible. We're going to learn all about it. We then get into a bonus material that I think is super exciting. And this is the IPFS, the Interplanetary File System. Sounds really cool. And well, you have to get to this part of the course to really understand what it is, but trust me on this, I think you're really going to like this section. Finally, our last bonus section, we're going to talk about SSH and public key authentication, something that's really important when we talk about security. And well, we've included here as a bonus for those that want to learn a little bit extra. As you can see, we have a lot in this course. Some would say a little too much, but that's the whole point of being a Linux sysadmin. You have a lot to learn, but once you learn this, a lot of this knowledge is going to transfer over for many years to come. We're going to take you from zero to mastery. Finally, the best part, as with all ZTM courses, is that you're going to get access to our online community. We have people here chatting every day, helping each other out, solving problems together, and talking about the latest and greatest in tech. Andre and myself are on there every day chatting with students so that you feel like you're part of a classroom. All right, as you can see, we have a lot to cover. Let's not delay things anymore. Let's get straight into it. Let's get started, and let's start our DevOps Bootcamp series.
In this lecture, we'll start talking about Linux distributions and which one is right for you. A Linux distribution, often abbreviated as distro, is an operating system made from a collection of software that is based upon the Linux kernel and often a package management system. This is the definition. The Linux operating system isn't produced only by a single organization, as in the case of Windows or Mac. Different organizations and people work on different parts of it. The operating system comprises the Linux kernel, the core of the operating system, which is common to all distributions and provides an interface between the hardware and the software and users. The GNU shell utilities, the terminal interface, and most of the command you use, the graphical desktop environment, and more. Distributed as source code, all of these components are open source and free software, and together they make up a specific Linux distribution. Even though they have different philosophies, the core and the main concepts are the same. In fact, if you learn how to use a specific Linux distribution, then you'll adapt and use another one with little or no effort. At the moment, there are hundreds and hundreds of distributions, each of them built for a specific purpose. Red Hat, CentOS, and even Ubuntu power the servers of the internet. Linux Mint is used for personal computers. OpenWRT runs on embedded devices like routers. Raspberry Pi OS is the system highly optimized for Raspberry Pi with ARM CPUs. And RUX cluster distribution is intended for high-performance computing clusters. Take a look at distrowatch.com. This website provides statistics and general information for various Linux distributions. This is the database of Linux distributions. DistroWatch creates a ranking of all the distributions out there based on the page hit ranking that shows the number of times a distribution page on distrowatch.com was accessed each day. This is a way of measuring the popularity of any Linux distributions. So if you are just starting out with Linux, you've probably already got overwhelmed. You just wanted to learn Linux, and now you find out that there are a bunch of Linux variants. If you want to use Linux for business or for building a career, then you should know that the most popular Linux distributions used in the industry today are Ubuntu and Red Hat Enterprise Linux. So to answer the question, which Linux distribution should I use, I make it really easy for you and tell you that you should choose between Red Hat and Ubuntu. You can forget about hundreds of other Linux distributions and choose one of those two or a distribution that is built on them. Large companies like banks, telecom, or retailers use Red Hat. However, Red Hat is a commercial distribution, so you have to pay a subscription fee in order to use it, and the fee is not low at all. By the way, Red Hat was acquired by IBM in July 2019 for $34 billion. But the good news is that in order to run Red Hat, it's not mandatory to pay for the license, and I'm not talking about pirating Red Hat. You can simply run CentOS, sometimes pronounced CentOS, which is another Linux distribution completely free based on Red Hat Enterprise Linux. CentOS is in fact Red Hat without branding and support. On the other hand, Ubuntu, which initially was itself based on Debian, is completely free. Ubuntu is used by startups, small companies, social networks, or by cloud-based services. Note that there are many other popular Linux distributions based on Ubuntu or Debian. I want to mention just a few of them. Linux Mint is a user-friendly distribution with an interface similar to Windows. This is perfect for beginners. MX Linux is another desktop-oriented Linux distribution based on Debian, which is a lightweight operating system designed to combine an elegant and efficient desktop with high stability and low resource consumption. And finally, Kali Linux, based on Debian as well, is a distribution used for ethical hacking, advanced penetration testing, and security auditing. It contains hundreds of security tools that run out of the box. This course is about Linux. It's not a Red Hat or an Ubuntu course. I want you to become an effective Linux administrator who will be able to efficiently run any Linux distribution. In fact, in today's ecosystem, a system administrator runs multiple distributions of Linux in virtual machines or in the cloud. That's why the concepts taught in this course are Linux distribution independent and can be applied to each flavor of Linux. We'll install both Ubuntu and CentOS, but we'll use mostly Ubuntu for common examples since it's more user-friendly and works well both as a desktop and as a server OS. But when things become different, I'll show you the same concept or tool on CentOS as well. Remember that Linux is Linux at the core, and no matter what distribution you use, the Linux concepts will be the same. As a final thought, I want to tell you that if you already have some experience with a specific distribution, or for some reasons you want to learn a specific Linux distribution, just go ahead and install it for this course. Now that you have a good understanding of what is a Linux distribution and which are the most commonly used ones, we'll take a short break, and in the next lecture, I'll show you how to install Ubuntu in a VM step by step. Welcome back! In this lecture, I'll show you how to install Ubuntu in a virtual machine. We'll use VirtualBox because it's free, but you can use VMware as well. The hardware requirements for Ubuntu Desktop Edition are at least 2 GB of RAM and 20 GB free space on your disk. From my experience, I can tell you that an SSD hard drive is also very important for a smooth run. The first step is to download the VirtualBox installer for your OS, probably Windows or Mac. The installer can be found on the download page here. Download the binary version for Windows, Mac or Linux. It's downloading. It's done. After downloading it, run the executable to begin installing the software. The installation process is straightforward. Just click Next a few times and at the end, finish. We won't go deeper into this because it's really simple. After installing VirtualBox, it's recommended to install VirtualBox extension pack on the host machine to unlock advanced VirtualBox features such as support for USB devices, flash drives, and many more. So download the VirtualBox extension pack from the same address and install it. There's a single file for all platforms. This is the file. It was already downloaded. Double-click the file, confirm the installation, and click the Install button. We are done with VirtualBox and we'll go ahead and download Ubuntu. In case you are wondering, Ubuntu is an African word meaning humanity, and it's often translated as humanity towards others. The latest version of Ubuntu uses the GNOME shell as the default graphical user interface, and this makes a resourceful system. If you only have an older system available, you could try a lightweighter desktop environment such as XFCE that runs on Ubuntu, or LXDE which runs on Ubuntu. We are talking about the same system, only the GUI being different. I'm also a fan of Linux Mint, which has a very friendly user interface. If you have enough space on your disk, you can try them all. There are three possibilities for the installation. To install it as the main OS, and in this case, we download the provided ISO file, create a bootable USB disk using a special software, and then boot up the machine using the USB disk. I'd recommend you to do so only after you get used to it a little. The second option is to use it live, and that means that Ubuntu will not be installed on your machine, but will run directly from a USB disk. And the third option is to install it as a virtual machine. This is the recommended way for beginners because there's no risk of breaking your main system. You can also download and try many other Linux distributions to see which fits you better. The same steps shown in this video will apply to any other Linux distribution. We go ahead and download the latest LTS version of Ubuntu. LTS stands for long-term support, which means 5 years of free security and maintenance updates. Ubuntu 20.04 is available only as a 64 version. There isn't a 32-bit version. Note that Ubuntu follows a biennial release cycle, with one release coming in April and other in October. An Ubuntu release has the version number in the format year, that month. So Ubuntu 20.04 was released in the 4th month, April, of the year 2020. Besides the version number, each Ubuntu release has also a code name. Focal Fossa being the code name for Ubuntu 20.04. It's almost done. Note that you also need a good internet connection to download the Linux ISO file and update the software. I've already downloaded the ISO file to save time, and now it's on my desktop. Start VirtualBox and click on the new icon to create a new virtual machine. Give it a relevant name like Ubuntu 20.04. Its type will be Linux and its version Ubuntu 64-bit. Click Next. The next step is to allocate RAM to the VM. 4 GB is recommended, but if it's not possible, allocate at least 2 GB or something in between. Bear in mind, the more RAM you allocate, the faster it will run. Note that you can change this value anytime, so you can test different values. Now it's time to create a virtual disk. This serves as the hard disk of the virtual Linux system. It is where Ubuntu will store its files, and it's completely isolated in a single disk file. Click Next and leave the default selection for the hard disk file type. In this step, leave the default selection, which is dynamically allocated. The disk file will only use space on your physical hard disk as it fills up, till the maximum fixed size you'll be setting up in the next step. Now it's time to select the file location and size. I'd recommend you to use 20 GB or more. If possible, for maximum performance, the location should be on an SSD disk. I'll leave the default location and click Create. Now, it's time to boot the Ubuntu ISO we've just downloaded and install Linux as a virtual operating system. I'm selecting the VM and clicking Start. Now I have to select the startup file, which is the ISO file. I'll browse to its location on my desktop by clicking the folder icon. In this window, I'm clicking Add and going to my desktop to select it. The ISO file was selected and I'm clicking Choose and then Start. Now it's time when you can get an error related to AMDV or VTX while trying to start the VM. This means that the virtualization or VTX is disabled in your computer BIOS. Reboot your system and access the BIOS settings using a function key that is specific for a computer or laptop model. Look for something related to virtualization or VTX and enable it. Save, restart the system, and then start the VM again. Let's return to the Ubuntu installation. It has started, and in a few seconds, I am presented with two options. I could try it as a live OS, or I could install it. And of course, I'm clicking Install Ubuntu. In this window, I can choose the keyboard layout. In my case, it's English US. In this window, I'll leave the default options, which are normal installation and download updates while installing Ubuntu. This option requires an active internet connection since it will update the system while installing it. The installation process will take a longer time. Now, depending on what you want to do and how quickly you want to install it, you can leave this option unchecked or not. You can also update the system anytime after installing it. I'll select both options and click Continue. If, like myself, you install Ubuntu in a VM, leave the default option and click Install Now. If you are installing Ubuntu as your main operating system, this step is very important. The default option will delete all your data and you'll format your disk. Maybe you want to try a custom installation type by selecting something else. You'll be able to manually select, create, and format your partitions. However, make a good backup of your files in this case. I'm clicking Install Now. Select your location and click Continue. And in the last step, write your name and your computer's. The computer name will be the host name that will be displayed as part of the prompter. Pick up a username and choose a password. Student and the password. And you are done. Depending on your hardware and your selections, it may take around 10 minutes to complete the installation. I'm pausing the recording until it's done. The installation is complete and I'll restart it to log into the system. If it gets stuck on this screen, you may choose to close VirtualBox. And if you want to save space on your disk, you can delete the ISO file. It's not necessary anymore. Once restarted, I can log into Ubuntu with the user and password specified at installation. Great! The network card is put into NAT mode, so I can access the internet as well. I'm starting Firefox. I'm also starting a terminal to check the internet connection. I want to ping an IP address. Ping is working. And let's check a popular website like youtube.com. If you can't maximize the window, don't worry, because I'll show you how to fix it in the next lecture. That's how you install Ubuntu as a VM in VirtualBox. In the next video, I'll show you the top things to do after installing it. See you in a second. The first thing to do after installing a Linux distribution is to update all installed applications to their latest version. When you installed Ubuntu, you've created a username with a password. This is the user and the password used to log in. Many, if not all, administrative tasks, including updating or installing new software, must be started as root. Root is the Linux administrator, and we'll have a lot of talks about it in the next lectures. To run commands as root, which means with administrative rights, use the sudo command and the command you want to run as root. Let's see how this works. I want to run some administrative commands that fully update all installed applications. I'm clicking this Ubuntu menu, Show Applications, and searching for a terminal. And I'm opening it. Another quick way to open a terminal is to click on the desktop with the right mouse button. Then select and click Open in Terminal, and a new terminal window is opening. So in the terminal, write sudo apt update. It's asking for my password, and the command will run with root privileges. Note that it requires an active internet connection. When it's done, I'll run a second command which will actually update all applications to their latest version. Sudo apt full -upgrade. It's prompting the user to enter Y to continue or N to stop. Note that this command requires a good internet connection since it's downloading a lot of software. As a conclusion, if you prefix a command with sudo, you are prompted for your own password and the command will run with root privileges. If you are a complete beginner, don't focus too much on this. Just update the system because we'll really dive deeper into this in the lectures to follow. We are waiting for it to finish. I'll pause the recording until it's done. And it's done. The system was fully updated. The second thing to do is to install the guest additions in the host VM, so in Ubuntu. They consist of device drivers and system applications that optimize the guest operating system for better performance and usability. The most important features are better mouse integration, shared folders and clipboard between the host and the guest operating systems, better video support, and so on. Go to Devices in the VirtualBox top menu and click on Insert Guest Additions CD image. This is provided as a single CD-ROM image file that is called vboxguestadditions.iso and is located in the installation directory of VirtualBox. So it comes with the VirtualBox and it's already available. A new window pops up and you can choose Run. It's asking for a password because it will run as the super user, which is root. And it's installing the guest additions. It's adding some kernel modules and so on. And it's done. If there's any errors or you don't want it to run automatically, you can run it manually. In a terminal, move to the directory where the guest additions ISO file was mounted using the cd command. cd, a white space, /media, my username, student, and I'm pressing the tab key for auto-completion. And I'm hitting enter. This is the directory where the guest additions file was mounted. Let's see the contents of this directory by running the ls command. Here we see some executable files for different operating systems, including Linux, Windows, and Mac. We are running Linux, so we are going to run the Linux script, which is vbox linux additions.run. As root, I'm executing the script. Sudo bash and the name of the script. You can use tab for auto-completion. This is one way of executing scripts in Linux. And it's running. It's doing the same thing as before. After it has finished, it's recommended to restart the VM in order to load the new kernel modules. So you could simply execute the reboot command at this moment. I'm restarting the VM. After the system restarts, you will be able to resize the VirtualBox window and the Ubuntu screen resolution will be updated accordingly. Now it looks better. I can eject the VirtualBox additions. Also note that each version of VirtualBox, even minor releases, ship with their own version of the guest additions, while it's kept stable so that guest additions already installed in a VM should continue to work when VirtualBox is upgraded on the host. For best results, it is recommended to keep the guest additions at the same version, so repeat the process of installing the guest additions after upgrading VirtualBox. And the last thing I'd recommend you to do is create a snapshot of the current state of the VM. This is a very powerful feature because snapshots allow you to save a particular state of a VM. This can be useful when you want to test something or you are about to make a change to the VM, and you need to be able to roll back to a working instance if something breaks. This is our case. We'll run lots of commands, install and update software, create and delete files, and many more. As we are learning by doing, there's the chance that something will break the Ubuntu system. Instead of installing it from scratch, we'll only roll it back to this working state. This is a serious time saver. So to create a snapshot of a running VM, go to the main menu of VirtualBox, click Machine, and take Snapshot. It's a good idea to fill out the name and the description because you might take multiple snapshots and you don't want to get confused when restoring only a specific one. It has created the snapshot. To see the snapshots, in the VirtualBox Manager, click this icon and then Snapshots. You'll be presented with the taken snapshots. Say you are working in your VM and you make a change that breaks the system. What are the required steps to roll it back to one of the previous snapshots? First, the VM must not be running. You can restore a snapshot only if the VM is either in a saved state or it's powered off. So, I'm powering off the machine. I'm selecting the VM from the left pane of VirtualBox Manager and clicking on Snapshots. I'm selecting the snapshot I want to restore and then click Restore. In this window, I can create a new snapshot of the current machine state or not. This is supposedly the broken state, so I'm not selecting this option. I'm restoring it. It was restored, so I can start it. I advise you to play around with snapshots, as in my opinion, this is a must-use feature when working with virtual machines. In this lecture, I'll show you how to install CentOS in a virtual machine. The first step is to download the CentOS ISO file from the official CentOS website. I'm installing the latest version of CentOS, which is 8 at the moment, and I'll select a mirror server that is geographically closer to me. These servers act like backup servers and provide fault tolerance and availability. And I'm downloading the ISO file. You can download the DVD file, which contains all the applications, or a smaller one, the boot file. I'm downloading the boot ISO file. In fact, I've already downloaded the file to save time, and now it's on my desktop. The next step is to start VirtualBox. I suppose you've already installed it. I've shown you how to do it when we have installed Ubuntu. If, for some reasons, you don't have it, just go to virtualbox.org, click the Downloads link, and then download and install VirtualBox for our platform. The installation is very simple, and there's no point to show you this at the moment. Download and install VirtualBox extension pack as well. This is provided as a single file for all platforms. Let's return to CentOS installation. Go to Machine and click New. This will create a new virtual machine. Give it a relevant name like CentOS 8. Set its type to Linux and version to Red Hat 64-bit. I'm clicking Next. In this window, select the amount of RAM that will be used by CentOS. The recommended size is 2 GB, but the more you can give, the better it will be. Now it's time to create a virtual disk. This serves as the hard disk of the virtual Linux system. It is where CentOS will store its files, and it's completely isolated in a single disk file. Click Create and leave the default selection for the hard disk file and type. In this step, leave the default selection, which is dynamically allocated. The disk file will only use space on your physical hard disk as it fills up to the maximum fixed size you'll be setting up in the next step. Now it's time to select file location and size. I'd recommend you to use 20 GB. If possible, for maximum performance, the location should be on an SSD disk. I'll leave the default location and click Create. Now it's time to boot the ISO file we've just downloaded and install CentOS as a virtual operating system. I'm clicking the Start icon and then selecting the startup file, which is the ISO file. I'll browse to its location on my desktop by clicking the folder icon. In this window, I'm clicking Add, and I'm going to my desktop to select it. The ISO file was selected, and I'm clicking Choose and Start. It has started, and in a few seconds, you'll be presented with the grab menu and some options. I'm selecting the first option, which is Install CentOS Linux 8. After hitting Enter, it's possible to get an error. If you get this error, which is related to AMD V or VTX, while trying to start the VM, it means that the virtualization or VTX is disabled in your computer BIOS. Reboot your system and access the BIOS settings using a function key that is specific for a computer or laptop model. Look for something related to virtualization or VTX and enable it. Save the settings, restart the system, and then start the VM again. Let's return to the CentOS installation. I'm hitting Enter. Note that when you click somewhere in CentOS, the mouse pointer will be captured by the guest OS. To return the ownership of the mouse to your host OS, VirtualBox reserves a special key, the host key. By default, this is the right control key on your keyboard. So to release the mouse pointer, I have to press on the control key. I'm selecting the language and I'm clicking Continue. In the next window, a summary of the installation is displayed. Before continuing, I have to complete the items marked with this exclamation mark icon. I'm clicking the installation destination, selecting the virtual hard drive, and leaving the storage configuration to its default values. So, to automatic. And I'm clicking Done. Next, I'll set the network, so I'm clicking the network and hostname. In this window, I'm enabling the network interface, which, at least in my case, was disabled. Now it's on. I'll also change the hostname to CentOS 8. I'm clicking Apply and Done. Next, I'll click the software selection. If you want to install CentOS Server with a graphical user interface, then you don't have to do anything else. But if you want to install CentOS as a headless server or without a GUI, select the second option, this one. I'd recommend you to leave it as it is. And I'm clicking Done. Great, there's no exclamation mark. I can begin the installation. If you want to make other changes, like setting up the time and date, now it's the time to do it. I'm done, so I'll click on Begin Installation. The installation has started, and I have to set the root password and another non-privileged user. I'm setting the root password. And I'm creating a new non-privileged user. This is in fact the user that will be used to log into the system. Type its full name, username, and his password. I'd recommend you to select this option as well. Make this user administrator. And I'm done. The installation is still running. It will take a few minutes, maybe more than 10, depending on your hardware and internet speed. It's downloading a lot of software. I'm pausing the recording until it's done. And it's done. I'm rebooting it. After a successful installation, we need to restart the virtual machine. The ISO file used for installation was mounted on an optical drive or a CD-ROM. This time, we don't need the ISO file inserted in the optical drive, and I don't want it to boot up from that file again. So go to Devices, Optical Drives, and remove disk from virtual drive. If it says that's currently busy, then go ahead and force it to unmount. Restart the VM by going to Machine and Reset. Start the VM again, and it should probably boot into the new CentOS 8. Now it's booting into the new operating system. At the first boot, you have to accept the license. The distribution was released under GPL v2 license, which means it's completely free. I accept the license agreement and finish the configuration. And I'll be greeted with the welcome screen of CentOS. I'm logging in using the username and password created during installation. It will prompt you for some configuration like language, privacy, and so on. Just click on Next a few times. After that, it should display your desktop. Great. The network card is put into net mode, so I can access the internet as well. I'm opening Firefox. Let's see if I can access CentOS.org. And it's working. I have an active internet connection. If it's not working, check that your network interface is set to connect automatically. Go to this top arrow, Wired Connected, Wired Settings, and check that the wired interface is connected and set to connect automatically at boot time. Great! You now have a very nice Linux server distribution running. This lecture is only for people that may be thinking of switching to Linux completely. If you just want to learn Linux for a system administration job, then you can skip this lecture. I'm taking the perspective of a Windows user that may be thinking of migrating to Linux as its main desktop OS. You should know that I've done that more than 15 years ago and have never regretted it. Now, I'm using Windows just for some specific tasks, such as recording these videos. On the work PC and the laptop, I run only Linux. By migrating to Linux, you'll end up with a working and a more stable and secure operating system, which is really free and open. No more problems with licenses or pirated software. If you want to make the step, I recommend you a Linux distribution that is user-friendly. I've been using for years Linux Mint, which is similar to Windows. The latest version of Ubuntu is also a good choice. So many say that Linux is more difficult than Windows, but I'd argue with that. A modern Linux distribution is not harder, even for non-savvy users, it's just different. Let me walk you through the most important features of Ubuntu. The first thing you may want to do is to access the settings. Go up to the top, click this small arrow, and you'll have access to the settings. Here, you can make all kinds of changes to the way Ubuntu looks and behaves. For example, go to Appearance and you'll find there options for the window colors: light, standard, and dark. Many people prefer the dark theme, so you can enable it if you wish. Let's talk about the dock, which is the bar on the far left of the screen that contains icons for the most popular applications or the applications that are running. This is the dock. In this window, you can change the dock settings. You can set it to hide when any active windows overlap with it. You can change the size of the icons or its position on the screen. At the moment, we have the settings on the dock, and that's because any active applications will appear on it. In fact, it will display a red dot before each application that's running. If I start the Firefox browser, a red dot will appear just before the icon. It's running. You can also go to Activities, and it will show you all running applications for easy access. You can also access active applications by pressing the Windows key, which is called the super key in Ubuntu. And of course, you can move between applications using Alt and Tab as in Windows. On the bottom of the dock, we have the Show Applications icon that will bring up all applications currently installed. We can scroll up and down if we wish, or search for an application name in the search box. I have searched for the calculator. I'm starting LibreOffice Writer, which is an open source replacement for Microsoft Office. If you want to add a favorite application to the dock for easy access, just search for that application, for example, Calc. Click with the mouse right button on it and select Add to Favorites. And the Calc is on the dock. And to remove an application from the dock, just click on it with the mouse right button and remove from Favorites. If you want to install new applications, just go to Ubuntu Software. Click on the suitcase icon on the dock and the Ubuntu Software will open. The software catalog is being downloaded. This is the main interface of Ubuntu Software with application categories, including editor specs. You can browse the categories or search for a specific application by clicking Search or pressing Ctrl and F. I'm searching for Spotify. To install an application, just select it and click on Install. You need administrative privileges, so you'll have to enter your password. Simply put, if you choose a modern Linux distribution like Ubuntu 20.04 or Linux Mint, the transition from Windows will be fairly smooth. Some of the problems that might appear are related to some licensed applications that are not available on Linux. For example, if you work as a graphic designer and use Adobe Photoshop a lot, then you should know that it doesn't run on Linux. Of course, there are some alternatives like GIMP or Inkscape, but it's not the original product. However, most applications, like all major browsers, video conferencing software such as Zoom, or integrated development environment applications such as Visual Studio Code, run on Linux as well. And if you really need a Windows or a Mac application that's not available on Linux, you can always run Windows in a VM, install and start that application. And one final thought. Compared to proprietary operating systems like Windows or Mac, Linux has only one master, and that's you. Hello, and welcome to this lecture on the Linux terminal in depth. When someone starts to learn Linux, the first words he will hear about are command, console, or terminal. At first sight, they seem intimidating, especially for a complete beginner. But rest assured that at the end of this lecture, you'll know in detail what they are and what they do. Linux is an operating system highly oriented towards commands. Even though there are many graphical interfaces available, any effective Linux administrator will prefer running commands for different administration tasks. This is what makes Linux so powerful and flexible. There are hundreds of highly efficient commands, and knowing how to use and combine them makes you a highly efficient sysadmin. Let's see what a terminal is. It is actually called a terminal emulator and is a crucial part of any Linux system because it basically allows you to access the system through a shell. It's a program that opens a window and lets you write commands. There are a bunch of terminal programs available, but the most used one is the GNOME terminal, which is the default terminal in Ubuntu and CentOS. Other terminal emulator applications are Console, Xterm, Quake, or Terminator. Let's open the GNOME terminal. Go to Show Applications on the dock and search for Terminal. This is the GNOME terminal. Another quick way to open such a terminal is to click on the desktop with your right mouse button and then select Open in Terminal. Or the shortcut used to open a terminal is Ctrl, Alt, and T. I have started more than one terminal. Note that you can start as many as you wish as new windows or new tabs in the same window. If you want to start a new terminal in a tab, just click on this plus sign. In this window, there are 3 terminals running in 3 tabs. But what is a shell? Simply put, a shell is a program that takes commands from the user through the keyboard and gives them to the operating system's kernel to get executed. It's also called the command interpreter because it accepts commands from the user and then checks or interprets them to see if they are syntactically correct. And if they are, the shell will send them to the kernel for execution. The shell gets started when the user logs in a console or starts the terminal. In this terminal, the default shell was started. In this example, I've started a few terminals, and in each terminal the default shell has started and is waiting for the commands. I'm executing a few different commands. An important thing to know is that Linux is a case-sensitive operating system, which means that it's sensitive to the capitalization of letters. This is different compared to Windows, which is case-insensitive. From now on, we'll consider the commands and options as written in lowercase letters if I don't specify otherwise. So if I say run the IP address command, without specifying the case, it means the command should be written in lowercase letters. Let's get back to the shell. Imagine that any Linux command you want to execute from a simple file copy operation to a full system upgrade should be written into a shell, which in turn will check to see if the command exists and is syntactically correct before sending the command for execution. For example, this command .sa doesn't exist. There are several shells available, but the most widely used one is called bash. It is the default login shell for many Linux distributions, including Ubuntu, Linux Mint, Debian, CentOS, and macOS as well. If you run Windows Subsystem for Linux or WSL on Windows 10, bash is also the default shell. Other shell applications besides bash are Bourne shell, C shell, Korn shell, or Z shell. In this terminal, the bash shell was started. We've discussed terminals and shells, but didn't say a word about consoles. What is a console? The console is a special sort of terminal that starts if no GUI was installed, so the terminal and the console are similar. You start a terminal in a graphical interface and the console in a text-only interface. Modern Linux systems provide more virtual consoles. These are usually accessed through key combinations, which are Ctrl, Alt, and F1 to F8. So there are 8 virtual consoles, but one of them is already used if there is a graphical interface that has started when you've logged in. However, if you installed Linux in VirtualBox, it may be possible that the key combinations will be caught by the guest OS, not by the host OS, and won't work. Let's recap in a nutshell. The terminal is the graphical application where the default shell will start. This is a terminal called GNOME terminal, and the default shell, which is bash, has started. In the shell, which is the command interpreter, I can write commands and the shell will send them to the kernel to get executed. And finally, a console is like a terminal but is started in a text-only environment where no GUI or graphical user interface was installed or started. Note that in Linux world, at the keyboard, the shell, the terminal, and the console can all look pretty much the same from the user's point of view. Many times the terms terminal and console are used interchangeably. It's common to say, I run the command at the console, even though the command was typed in a terminal. Note that the GNOME terminal is not the only one. I'll install a new terminal emulator called Terminator, which provides several features that the default terminal application does not support. A useful feature is the ability to create multiple terminals in one window. So, in the GNOME terminal, I'm writing sudo apt update && sudo apt install terminator. It's installing the terminator. Sorry, I've misspelled it. It's install written with double L. I'm confirming it. It's done. And I'm adding it to the dock as a favorite application. Terminator and add to favorites. I'm also adding the default terminal to the dock. This is the Terminator. I'll also change the default theme to a lighter one for you to see it better. This is better, at least for recording. And if I want another terminal in the same window, I'm just clicking with the right mouse button and then split horizontally or split vertically. And I have two terminals. Let's go ahead and discuss the structure of the Linux commands. To give a command to a Linux system, you type in a shell the command's name, its options, and arguments if required. Let's get started with an example. I'm opening a terminal and the default shell, which is bash, was started. And I'm running ping -c1 8.8.8.8. As you probably already know, the ping command, which is available on Windows and Mac as well, is used to test the network connectivity to a destination host. For the moment, please don't focus on the actual command or on what it does. We'll have plenty of time to dive deep into each important command. Just focus on the structure of the command line and how I put things together. We notice that we have an active connection to 8.8.8.8, which, by the way, is a public DNS server from Google. This is how we check that the internet is working. If you have any issue with your internet connection, to continue with this example, you can ping your loopback interface IP address, which is 127.0.0.1. This is the IP address of your loopback interface. It will work even though you don't have an active network connection. Let's take a closer look at the command line. The name of the command is ping. C is one of the command's options, 1 is the options value, and the IP address, which was 127.0.0.1, is the command argument. It's important to know that all options are preceded by a hyphen, a minus sign. Note that the command name, its options, and arguments are always separated by one or more white spaces. In fact, the shell knows that the command name ends where it sees the first white space. The command name has ended here, before -c. Note that it's common to separate the command name, its options, and arguments by one white space, but there's nothing wrong if you write more white spaces. This is correct as well. It's fairly standard that the options must come after the command name and before any command arguments. However, there are variations and commands that permit options after the main argument, like this. I'm removing -c1 and I'm writing it at the end, -c1. By the way, it means that it will send only one ping packet to the destination. This is the same, but it's not common. In the examples of this course, we'll follow the standard and we'll write the options after the command name and before its arguments. In Linux, there are commands that require some options or arguments and return an error if they are run without arguments. And there are other commands that do not necessarily require options or arguments. For example, if I run the ping command again, this time without any option or argument, I'll get an error. It says destination address required. It's mandatory to specify an argument. But if we take another command, say ls, we'll see that we can run it both with and without options or arguments. By the way, ls is probably the most used Linux command. Its name comes from list and it displays or lists information about the file system. In this example, the ls command has displayed the contents of the current working directory. Now, let's run it with an option and an argument. -l option tells ls to use a long listing format, and /etc, which is the argument, indicates what directory to list. Using the options, we change the comments behavior. Note that some options can be written using a hyphen or a minus sign and a single character such as -l or double hyphens and an entire word. So ls --all and ls -a are similar. It's the same command. By the way, this option -a or --all will display the hidden files and directories as well. Note that we can use more options, not only one. In this example, I'm using both short and long options. And it's common to group all short options together like this. See how I've grouped the L and H options together. The last two commands have the same effect. They are equal. Let's see one last example. I'm running a command without any option. df. The same command with a single option in short format. The command with two options. The command is df. Or I can group the options. I can also add a third option in long format. By the way, the df command displays information about the file system and the disk space usage. Okay, that's all about the Linux commands structure, options, and arguments. This lecture is really important if you're a complete beginner. Take your time to deeply understand each concept and rewatch the video until you feel confident about it. Linux comes with hundreds of commands, each of them with lots of options. It's impossible even for an experienced Linux administrator to remember all the commands and their options. Fortunately, Linux comes with its own help built-in system. In this lecture, we'll be talking about man pages. Man is short for manual, and a man page is simply the documentation of a program or command. You can use the man command to read the documentation of a specific command. To open the man page of a command, you type in the terminal man and the command's name. Let's open the man page of the ls command. I'm writing man ls. By default, man uses a program called ls to display the output. While you are in the man page, you can get additional help by typing the letter H. I've just typed H. You see this title, Summary of ls commands. This means that the man command used the ls command to display the help. For a beginner, it could sound weird, but there's a command called ls used to display the contents of the text files. It's a viewer or a pager. To get out of this screen, you press Q, and to exit or to get out of the man program, you press Q, which comes from quit again. Let's open the man page of ls again and see what is its main structure. You'll find the same structure for all man pages. The first line contains the name of the command you are reading about, along with a very short description. Then comes the synopsis of the command, which provides a formal description of how to run it. In this example, we run it as ls, some options, and some files as arguments. In a man page, everything that appears directly before three dots, which are also called ellipses, can be repeated. So you can repeat different options and also file names. This means that you can specify more than one option or file. Options and arguments are put between square brackets to indicate that they can be left out. They are not mandatory. This is the case of ls. We can run it both with or without options and arguments. Other conventions used in man pages are: when you see bold text, you are supposed to type in exactly as seen. But when you see an underline or italic text, you need to substitute it with something appropriate. Here, we don't write size, S-I-Z-E, but we have to specify the size, the actual size. After the synopsis, a longer description of the command is given together with all its available options. When you see an option in short format, a comma, and an option in long format, it means that you can use any form you wish. Note that some man pages contain an extra section called options, where the options are explained. Take a look at the man page of the df command. This is the options section. At the end of the man page, there are the author, the copyright, and see also sections. Let's go ahead and talk about the navigation within a man page. Let's see the most important navigation keys. Use the arrow keys to move a line up or down. Up and down. To forward one window, press on Ctrl and F or on the space key. I'm forwarding one window. I'm at the end. And if you want to move backwards a screen or a window, you press Ctrl and B. I'm moving backwards. And to go to the very beginning of the man page, type lowercase g. I'm at the beginning. And to go to the very end, type uppercase G. I'm at the end. Sometimes you want to search in the current man page for a specific option. Let's say we are in the man page of ls and we want to find matches for sort within that manual page. First, I'm going at the beginning. So I'm pressing G. What I'll do now is write a backslash and the string I want to search for. Sort. And I'm hitting enter. Any matches in the current man page will be highlighted. You can then navigate between matches with N, like this, or Shift N or uppercase N. N will take you to the next match, and Shift N or uppercase N will go to the prior match. So backwards. When you search using a forward slash, the searched term, it is searched forward. But if you are, for example, at the end of the man page, so I'm pressing an uppercase G to go to the end, and want to search backwards, then you type a question mark and the searched term. Or -u. I was searching backwards for -u and it found a match which says that the option is used not to sort file entries. Okay, those were the most important things about man pages that I think you should know. Also note that there are two types of commands in Linux. Commands that are executable files on the disk and shell built-in commands. The last ones are built into the shell and most of the time they don't have a dedicated man page. I'm quitting, pressing Q. To check if a command is an executable file or a shell built-in, use the type command. So type df. It's displaying the path to the command. Or type apt. All these commands are executable files and have their own dedicated man pages. But commands like cd, alias, or umask are shell built-in and do not have a dedicated man page. All these commands are shell built-in. To see the help of such a command, instead of man, use the help command and the command name. So help cd. and you see its help. So cd is used to change the shell working directory. Note that you can use the help command only for shell built-in commands and not for commands that are executable files on the disk. So help ls is not working. But another way to get some help is to write the name of the command and --help. This is available for both shell built-in and executable files commands. So rm --help or ls --help or cd --help and so on. I'll introduce you a new command which is ifconfig. This is used to both display information about the network interfaces and configure them. If you want to see the IP or MAC address of a network interface, you have ifconfig at your disposal. ifconfig belongs to NetTools package. If, when running ifconfig, it says command not found, then you should first install the NetTools package. Run as root on Ubuntu, apt install NetTools. So sudo, the command will run as root, apt install NetTools. Or on CentOS, dnf install NetTools. Sudo dnf install NetTools. On CentOS, it's already installed. And a final trick I'd like to give you is how to search for a command, feature, or keyword in all man pages. To do that, use man -k and the keyword you are searching for. Let's say man -k ifconfig or man -k uname. You can also pass a string enclosed in double quotes as argument. Man -k copy files. It will search for the string copy files in all man pages. And it found 3 commands. Note that man -k is similar to the apropos command. So apropos and the command ifconfig or apropos uname. It's the same. In these examples, it has searched for ifconfig respectively uname in all man pages and has displayed the commands that contain references to the searched keyword. Now, if I want, I can check the man pages of those commands to dive deeper. For any Linux professional user, the command line is an essential and ultra powerful tool. In this lecture, I'll teach you how to be really efficient when using the terminal. The most important advice I could give you is to use the tab key for auto-completion. This is something you cannot live without. It will not only save you so much time at the Linux command line, but it will keep you from making mistakes as well. Tab is a feature supported by Bash and other shells as well. If you have to remember only one shortcut, this should be the chosen one. How it works is really simple. When typing at the Linux command line, just use tab to auto-complete commands, file names, or folder names. To use this feature, type the first few letters of the command you want to run or the file name you work with, followed by tab. Bash will scan the current directory as well as all other directories in the search path for matches to that name. If a single match is found, Bash will automatically complete the file name for you. If multiple matches are found, you have to press the tab key twice and it will show you all results and you should continue typing until there's only one match. Let's see some practical examples. In my terminal, I write the letters IFC and press Tab on my keyboard. The shell has automatically completed the command for me. Note that the letters ifc uniquely identifies the ifconfig command, and that's why it has automatically completed it. But if I write if and press Tab, nothing happens. Do you know why? Because there's more than one command beginning with the letters I and F, and the shell doesn't know which one I'm referring to. What I can do is press Tab twice, and it will display all available commands that start with I and F. And there are two. Then I can continue typing until it can uniquely identify the command and autocomplete it. Let's see another example. Tab is used to autocomplete both the commands and the files or directories. I'm writing cat, a white space, a / and E, and I'm pressing Tab. It has completed the etc directory from the root directory, which is / because there's only one directory that starts with the letter E, and that's etc. I continue and type the letters PA and press Tab. Nothing happens because there's more than one file or directory beginning with PA, and the shell doesn't know which file or directory I want. But if I press Tab 2 times, it will display all the files and directories that start with PA and are in the /etc directory. And there are 5. I'm typing the next letter, which is S, and pressing Tab. Now the shell knows what I want and autocompletes the entire file name. By the way, the cat command displays the entire contents of the file at the terminal. Now it's time to tell you something really important, something that in my opinion is the key to not make serious mistakes while working in the Linux terminal. If Tab does not complete automatically a command or a file name when it should, then there's a mistake. Do not continue writing the command or the file name, but stop and analyze what you have done up to that point. Tab doesn't complete because somehow, somewhere, there's an error. For example, let's suppose that by mistake, I'm writing a white space before the P letter like this. I'm hitting Tab and nothing happens. It would be a mistake on my part to try to write the file name manually. I've got 2 errors. What I should do is analyze the command line and try to find the error, like this white space here. I'm removing it and then hitting Tab, and it completes the file name. Another common mistake is to try to write the file and directory names manually instead of using Tab. Let's suppose I want to remove a file in /var/log directory. Like this. rm and the full path to that file. So /var log and the file. A random file, it doesn't matter. I won't remove it anyway. Don't focus on the rm command, which is used to remove files and directories, because we'll have plenty of time to talk about it later in the course. Instead of using Tab autocompletion, like I actually did, I write the path manually. There's the chance that by mistake, I'll write a white space before the file name, like this. The effect will be that the rm command will consider that 2 arguments were given, /var/log and the file, and will try to remove them both. So instead of removing that specific file, you could remove the entire /var/log directory, which will break your entire system. Such a mistake is avoided if you always use tab completion. I hope that this lecture has provided you with a good understanding of how tab completion works and how to properly use it. A Linux administrator spends most of his work time in the terminal. In this lecture, I'll show you a list of useful bash shortcuts that every Linux admin should know if he wants to get things done faster. Let's get started. Ctrl and L clears the screen. If there's anything on the screen, you can clear it by pressing Ctrl and L. It's similar to running the clear command. Ctrl and D closes the bash shell. It's similar to running the exit command. I'm pressing Ctrl and D. The shell was closed. I'm opening the terminal again. You can also type exit. Ctrl and A moves the cursor to the beginning of the line. This is useful if we run a command on a file and then we want to run another command on the same file, like I'm running ls-l etc password, and now I want to run the cat command on the same file. Instead of writing the command again, I can press up the arrow key to recall the last command and then press on Ctrl and A to move the cursor to the beginning of the line. Now I can simply replace ls with cat and run the new command. Of course, I have to remove the -l option, which is an option of ls. By the way, up arrow key retrieves the previous command. If you press it constantly, it takes you through multiple commands in history, so you can find the one you want. Use the down arrow to move in the reverse direction through the history. Another useful shortcut is Ctrl and E, which moves the cursor to the end of the line. I'm pressing Ctrl and E, and the cursor was moved to the end. I can continue writing. Another useful shortcut is Ctrl and U, which deletes all characters before the cursor by cutting and adding them to the clipboard. Let's consider this command, and you want to execute another one. Instead of pressing on backspace multiple times, you could press Ctrl and U. Ctrl U is also useful when you type in a password and after a few characters you realize you made a mistake. I have typed a few characters and I've realized I did a mistake. Instead of pressing on backspace multiple times, I could press Ctrl U. The entire command line was deleted. Let's move on and see another shortcut. To interrupt the process running in the current terminal, press Ctrl and C. Let's say you run a command that takes some time and want to stop it. Then you press Ctrl and C. For example, I'm gonna download a very big file using wget, and after a few seconds I'll decide that I want to stop it. And I'm stopping the command, pressing Ctrl and C. It was stopped. Or another one. Ping and an IP address. Without any option, ping will send packets continuously. I'm stopping it by pressing on Ctrl and C. It was stopped. Note that Ctrl and Z does not stop the current running process as Ctrl C does, but only suspends or pauses it, and it can be resumed later on. I'm pressing on Ctrl and Z. The process was not interrupted, was just stopped. The difference being that I can resume it anytime later. For example, big G, %1, and the process was resumed. We'll talk more about these concepts in the process section. Let's talk about bash command history. The bash shell stores in the user's home directory the history of the commands each user has run in a file. The file is .bash_history by default. The number of commands that will be stored in the history file is controlled by an environment variable called hist_file_size, written in uppercase letters. Remember that in Linux, everything is case sensitive. To print the value of a variable, run echo, the $, and the variable name. In this case, hist_file_size. This is the variable. And we notice that this Linux system saves 2000 commands into the history file. You can print out the entire bash history to the screen by running a single command, which is history. I'm running history. These are all the commands saved in history. You are seeing a list of commands in your bash history along with a number to the left of each. The command with a 1 next to it is the oldest command in your bash history, while the command with the highest number is the most recent one. And of course, the most recent command run was history. Note that running the history command does not mean listing the entire contents of the history file. There's another variable called hist_size that controls how many commands from your bash history will be stored in the memory. Let's see its value. And it's 1000. So let's draw a conclusion. Bash will save maximum 2000 commands in the bash history file in the user's home directory and maximum 1000 commands in the memory. These are the commands displayed by the history command. So the history command will display only half of the commands saved in the history file. Also note that the history file is updated only when the user that ran the commands logged out. I'm running the command IP address show. The command is displayed by the history. Look, this is the command, but it's not in the history file. It's not there. Now I'll log out. I'm logging in again. I'm opening the terminal again and checking the history file. And the last command is in the history file. To run a specific command from the history by its number, use an exclamation mark and the command number. For example, I want to run the 17th command from my history and I'll type an exclamation mark and the number 17. And to rerun the last command you ran, type 2 exclamation marks. This has the same effect as pressing the up arrow once to view the previous command and then pressing enter. You can also refer to a command from a certain number of lines back in the bash history. For example, an exclamation mark and -7 would run the last 7th command. The command was rm1 and it was an error. Let's try another example. I want to rerun the who command. So, an exclamation mark, -3. And the command was executed. To search for a command in your history and run it, type an exclamation mark and the command name. For example, I want to run the last ping command, and to do that, I'll type an exclamation mark and the command. And I'm hitting enter. And it's running the last ping command. I'm pressing Ctrl+C to stop the ping. Note that this can be also dangerous because you don't know exactly how the command was executed, and there's the risk of executing another command. What you can do is append :p to the above expansion, and bash will print out the command to the terminal without running it. This is useful if you want to confirm that you've selected the correct command before running it. Like this. It's just printing the command. It's not running it. And if the command is correct, I can run it. Let's move on and see how to walk through the command history. Ctrl and P or up arrow are used to go to the previous command in the command history. Press the shortcut multiple times to walk back through the history. And Ctrl N or down arrow will go to the next command in the command history. Press the shortcut multiple times to walk forward through the history. Bash also has a recall mode you can use to search for commands you've previously run. Press Ctrl and R and start typing a command to search your bash history for it. I'm pressing Ctrl and R and I'm typing PI and it has found the command. When you find the desired command, you press Enter or Ctrl and P to run it. I'm pressing Ctrl and R again, type cat, and now I do not want to run the command. And I'm pressing Ctrl and G to leave the history searching mode and clear the line. I'm pressing Ctrl and G. There may come a time when you want to remove some or all the commands in your history. If you want to delete a particular command, enter history -D and the line number. For example, I want to remove this command. So history -D and the line number. The command was removed from the history. It's not there anymore. To clear the entire contents of the history file, execute history -C. The entire history was removed. It's empty. At the end of this lecture, I have a small homework assignment for you. The command history is a very powerful feature of Bash, and using it efficiently saves you a lot of time. However, there are moments when you want to run a command without saving it to history. Let's suppose you want to copy or view a file you are not supposed to, connect to another machine you are not allowed, and so on. How can you run the command without leaving any trace? Think about it, try different ways to manage that, and even search on Google for a solution. We'll take a short break, and in the next lecture, I'll show you how to do it. Let's suppose we want to run a command that shouldn't be saved in history. For this example, I'll use wget and download a file locally. And I'll download the logo image of Google. This one. Copy image location, and in the terminal, I'm writing wget, and I'm pasting the contents of the clipboard. The file was saved locally in the user's home directory. This is the file. Now the admin or other users that have access to this account can see the command I've run by executing history. What can I do? If I erase the history by running history -C, it will look suspicious. Why would someone erase his entire history? If you manually edit the history file, the command that opens the file for editing will be saved in the history as well, and it's not good. This will be saved in the history. It's not good. A possible solution is to type a space in front of a command before running it in the bash shell, and the command will run normally but won't appear in your history. Let's do it both on Ubuntu and CentOS. I'm running the who command, which will display the users logged into the system. And I'm checking the history. And of course, the command is there. Now, I write a white space and the command again. And I'm checking the history. And the command was not saved. who-a was not saved. Let's do the same on CentOS. I'm writing a white space and the command. And I'm checking the history. This time the command is there even though I've added a white space before the command name. So we see that the behavior is not the same on different Linux distributions. Let me tell you in detail how that works. There's a special variable called hist_control that allows you to ignore commands and not save them in bash history if you set the variable to ignore space. Let's see its value on both Ubuntu and CentOS. Echo, a $, and the variable name, hist_control. So, hist_control is set to ignore both on Ubuntu. And now on CentOS. Don't forget to write a $, before the variable's name. On CentOS, the variable is set to ignore dups. Let's set it to ignore space on CentOS. Hist_control, written in uppercase letters, equals ignore space. Ignore space, written in lowercase letters. Now, I'm running a command adding a white space before its name. Let's check the history. And the command was not recorded. But what will happen if I run the same command multiple times? Will it record each command or ignore duplicates? I'm running the cd command multiple times. 5 times. And I'm listing the history. We see that it has recorded each command, which maybe it's not what we really want. Maybe you want your history a bit cleaner by ignoring duplicate commands that can clutter it. You can set the hist_control variable to ignore dups, which stands for ignore duplicates, the way the default in CentOS is not to save duplicate commands in history. So I'm modifying the variable. Hist_control equals ignore dups. Ignore dups written in lowercase letters. And I'm running another command multiple times. Let's see the history. It was saved only once. Now to use both the ignore space and ignore dups features, set the hist_control variable to ignore both like is the default in Ubuntu. It will save nor the commands that are prepended with a white space, neither duplicates. Note that bash variables you set will only persist for the current session. After you log out or restart your system, the settings will be lost. To save the settings after the system reboots or the user logs out, you have to add the settings to that .bashrc file in the user's home directory. We'll talk more about that when we discuss editors and bash scripting. For the moment, the easiest way for you to do that is by running echo, the setting you want to save, hist control equals ignore both, double greater than symbol, and the path to the file, .bash rc. This command has appended this string to the end of the file. By default, the history command will display the output as the number of the command in the history and the command. This command didn't display at what time the commands were executed. For auditing purposes, it may be helpful to display the timestamp along with the command. To solve this problem, we'll set the environment variable called hist time format like this. Hist time format, written in uppercase letters, equals, and between double quotes, the following string. %d, a forward slash, %m, another forward slash, %y, a white space, and %t, capital T. %d represents the day, %m is the month, %y the year, and %t, capital T, the time. Of course, you can format it any way you wish. Now, let's run some commands and then the history command again. And I'm running the history command. And we see date and time information attached to each command. In your case, before setting the hist time format variable, no time information was recorded in the history, so it couldn't know at which time those commands were executed. The history command is displaying the time the hist time format was set for all those commands. So for all commands, run before setting the variable. In my case, you see the date and time information for all the commands because before recording this video, I was playing around with the variable. If you want the setting to be persistent after system restarts or the user logs out, you need to add it in the .bashrc file. So echo the command between double quotes, two greater than signs, and the file .bashrc. Let's see the file. Okay, the setting is there. From now on, it will record date and time information for all commands. Let's talk about Linux users, one of the key concepts in Linux. On each Linux system, there are two main categories of users: non-privileged users and root, which is also referred to as the superuser or the administrator. Root exists on any Linux system. Root privileges are the powers that the root account has on the system. The root account is the most privileged on the system and has absolute power over it. Among its privileges are the ability to run any command or to access any file on the system. Actually, it can do anything on a Linux system, such as installing a new software or updating the existing ones, setting up the network, changing the ownership of files, managing other users' accounts, or administering any service that's running. On the other hand, all other users, which are called non-privileged or normal users, have no special rights on the system. They can only work in a directory called user home directory and cannot perform any administrative tasks like installing new software, creating other users, or running administrative commands. Because root is so powerful, it's not recommended to use it for ordinary tasks such as browsing the web, writing emails, or documents. Even a simple mistake, like for example a mistyped command, can cause problems to the entire system. So, for ordinary tasks, it's highly recommended to use a normal user account. And when root permissions are needed, you simply become root only to perform that particular administrative task. On many Linux distributions, like those based on Debian or Ubuntu, the direct logging in as root is prohibited. Let's see how to gain root access in the terminal. There are more approaches and I'll show you all of them. The first way to temporarily become root in a terminal is to run sudo su. By the way, sudo stands for superuser and su stands for substitute user. It's asking for the user's password. Note that this is not the root password, it's the non-privileged user's password that ran the command. I'm entering the password, and if the password is right, and the user is part of a specific group which is called sudo on Ubuntu and will on CentOS, then a new shell with root privileges starts and the user can run their administrative commands as root. You can say that you've temporarily become root in that terminal until you log out from it. To see the user you are currently logged in, run the id command. This command brings out the logged in user and the groups it belongs to. To log out, you type exit or press Ctrl and D. Note that when becoming root, if you add a white space and a hyphen after su, then the root working environment is activated. The current working directory was changed to the root home directory. This executed all of the root user's shell initialization scripts and set all environment variables as if the root user was logged into a fresh shell session. By convention, on Linux all users prompt ends in a $sign. Root is the exception as xprompt ends in a hash. A second way to run commands as root is without logging into the root account, but by using the sudo command and the command you want to run as root. If you prefix a command with sudo, you are prompted for your password, not the root password, and if your user belongs to a specific group, sudo on Ubuntu and will on CentOS, the command will run with root privileges. Let's see how this works. I want to run an administrative command that creates a new group. If I run it simply by typing the command, I'll get a permission denied error. Only root is allowed to run the group add command and create a new group on the system. I'm simply running the command. And I've got a permission denied error. Now let's write sudo before the command name. And the command was executed successfully. A new group was created. Note that I'm not logged in as root, but as the initial normal user. I'm student. Using sudo makes it much more difficult to forget that you are root since you are not logged into the root account and you don't need to log out after you've finished your job. Let's try to run a second command as root. This time, I'm gonna create a new user on the system. Sudo user add John. And you notice that the command ran as root without asking for any password, as in the first example when I ran the sudo command. That's because the sudo policy caches for 5 minutes the credentials I've entered in the first place, and anytime I run the sudo command, the timestamp is updated to 5 minutes. In this example, after I ran the sudo user add command, I could run other commands as root without being asked for any password for exactly 5 minutes. By running sudo with the -v option, a user can update the cached credentials without running a command. And if I want to invalidate the user's cached credentials, I need to run sudo -k. In other words, the next time sudo is run, a password will be required. Let's create a new user. And a password is required. The last method of running commands as root is to temporarily become root in that terminal by running the su command and entering the root password. Note that on some distributions, like Ubuntu based, this method is by default disabled because direct access to root is locked. Remember that you have installed Ubuntu in the first place without setting a password for the root account. To unlock the root account on such a distribution, you simply have to set X password. Note that not having a password doesn't mean that without it you can log in as root, but on contrary, it means that you cannot log in at all. I'm setting the root password. The command used to change a password in Linux is PA_SSWD. So sudo PA_SSWD and the username, root. X prompting for my password so that the command will run as root. I'm entering my password. And now the new password for the root account. I enter it 2 times. Note that on Linux, when you are entering a password, it doesn't display it. It's a security measure so that no one can find out how long the password is. Type the password even though you don't see it. Now, I can temporarily log in as root by running su and entering the root password. So su, and I'm entering the new root password. And I'm root in this terminal. This method of becoming root is available only in a terminal. You are still not allowed to log in as root in the graphical environment. On CentOS, this method of becoming root is by default available, and the root password is the one you've set at installation time. I am entering the root password. And I'm root. Note that a user can change its own password by running the password command, and root can change the password of any user by running the password command, and the username whose password will be changed. Root is changing the password of a user called student. The password shouldn't be shorter than 8 characters. That's all. You've just learned how to run administrative commands as root in Linux. At the end of this lecture, I want to clear for you that the word root has also several additional related meanings when used as part of other terms. This can be a source of confusion for the newcomers to Linux systems. Let me give you some examples. One of the most frequently met terms is the root directory, which is the top-level directory of any Linux file system. All other directories and files reside in this directory. The root directory is designated by a /. This is the contents of the root directory. Another term is /root. This is the root user's home directory. A home directory is the primary directory of a user's file, and it's actually the directory in which a user finds itself when it logs into a system. /root is a subdirectory of the root directory as indicated by the / at the beginning, and it should not be confused with that directory. This is root, and this is /root. Home directories for users other than root are by default created in the /home directory, which is another standard subdirectory of the root directory. This is where the home directories of the other users are located. Hello, and welcome to this section on the Linux file system. A file system controls how data is stored and retrieved. Without a file system, data placed on a storage medium, like a hard disk drive or USB stick, would be one large body of data with no way of telling where one piece of it stops and where another one begins. By separating the data into pieces and giving each piece a name, the data is easily isolated and identified. Before computers, the term file system was used to describe a method of storing and retrieving paper documents. Now, each group of data is called a file, and the structure and the logic rules used to manage the files and their names are called file systems. In other words, a file system is a logical collection of files on a partition or disk. Your hard drive can have multiple partitions, which usually contain only one file system. On a Linux system, everything is considered to be a file, including physical devices like a USB stick. Even a directory is also a special kind of file, and if something is not a file, then it's a process. On Linux, the structure of the file system is hierarchical. Much like an upside-down tree, the root directory, which is a /, lies at the base of the file system, and all other directories are spreading from there. Note that most of the times, the terms folder and directory are interchangeable. Directory is a classical term used since the early times of the file systems, while folder is a sort of friendly name which may sound more familiar to Windows users. A directory is a file system concept, and the graphical user interface metaphor that is used to represent it is called folder. So a folder is more like a graphical interface object. However, I think that's not such a big deal if you use them interchangeably. There's also the concept of file system hierarchy standard, or FHS, which defines the directory structure and contents for Linux distributions. Let's go to the terminal and list the contents of the root directory. This is the contents of the root directory, the /. In the file system hierarchy standard, all files and directories appear under the root directory even if they are stored on different physical devices, like on different disks or partitions. This is one of the differences when comparing to Windows file system, where there isn't such a unique file system tree. Imagine that on Windows you can have more partitions or disks which are accessed as drive letters in my computer without a common directory at the base. In Linux, there is only one file system tree under the root directory at the very top. When you want to access an additional file system, like the one on a USB stick, you need to mount it or logically attach it to an existing directory of the unique file system. That directory is called mount point. Just to make it clear, I'll insert a USB stick. If you've installed VirtualBox extension pack, you'll be able to access the USB stick in the VM. To make it available to the guest OS, in the VirtualBox window, go to Devices and then select the USB drive. This is the drive. Now it's available on Ubuntu. On most modern Linux distributions, a USB drive will auto-mount when you insert it, but sometimes you may need to manually mount the drive. We'll discuss that in a future lecture where we'll talk about the system administration. For the moment, I just want to show you how the file system on the USB drive will be mounted in a directory of the existing file system. To see the mount point, you can run df-h. This is the disk. You notice how it has been automatically mounted in /media/student, the username, and the name of the disk. You can access its contents in that directory. This is the contents of the USB disk. You can access it in the graphical environment as well. Note that there are no drive letters like in Windows. Now that you have a basic idea about the Linux file system, we'll take a short break, and in the next lecture, I'll talk about the common directories of any Linux file system. See you in a second. The Linux directory structure is well defined and documented in the Linux File System Hierarchy Standard, or FHS, which is maintained by Linux Foundation. I'm listing the contents of the root directory of /. Most Linux distributions will show you the same or a very similar layout to what you can see in the output of the ls command. Let's get started and look at what each directory is used for. You can take a look at their contents running ls. In this video, I'll show you the directories both in the terminal and in the graphical file manager. To start the file manager, search for files and open it. Go to other locations and then access my computer. This is the root directory contents. The bin directory contains binaries or user executable files which are available to all users. For example, the ls command we've just run is in this directory, along with other basic tools for copying and removing files and directories, moving them around, and so on. This is the contents of bin. As you see, ls resides in this directory. There's another directory called sbin, which is similar to bin, but it contains applications that only the super user, hence the initial S, will need. These executables are used for system administration. Some examples are ifconfig, used for configure the network adapter, or fdisk, used to manipulate disk partitions. This is its contents. The boot directory contains files required for starting the system. You normally do not touch it. Home is where you will find your user's home directories. Under this directory, there's another directory for each user if that particular user has a home directory. In this example, the user called student has as home directory the directory called student under /home. It's common for the name of the home directory to be the same as the user's name. Note that tilde is the same as the user's home directory. So if I run ls tilde, it's the same as running ls home student. In this case, tilde equals /home/student, the current user's home directory. Note that root has its home directory separated from the rest of the user's home directories and is /root. This is the home directory of root. Of course, an unprivileged user is not allowed to see the contents of this directory. Let's take a look at other directories. Dev or dev contains device files. Many of these are generated at boot time or even on the fly. This directory contains the device files for every hardware device attached to the system, like a hard disk or a partition. These are not device drivers, rather they are files that represent each device on the computer and facilitate the access to those devices. Remember that in Linux, everything is a file and the disk partition is logically represented as a special file as well. Let's take a look at this file. /dev sda1. This is a file of type device that represents the first partition of the hard disk. Another interesting and well-known directory is etc. It gets its name from the earliest Unix operating systems, and it was literally etc. because it was the dumping ground for system files the system administrators were not sure where to put. On a modern Linux distribution, it contains most, if not all, system-wide configuration files. For example, the files that contain the users and their passwords, the groups, how the network is configured, or how a network service like a web or an email server is configured are all there. As a beginner, I'd recommend you not to touch it much, and it's always a good idea to make a copy or a backup of this directory. Let's take a look at another one. lib contains shared library files used by different applications. You don't touch this directory directly. The package manager can update it accordingly when you install, remove, or update an application. The media directory is where the external storage will be automatically mounted when you plug it and try to access it. When you insert an external hard disk or a USB stick, they will be automatically mounted and made available for you under /media. And MNT is like media, but it's not very often used these days. It was the mount point for the CD-ROMs or the floppy disks. However, when you need to quickly mount a partition and don't know where, you always have /MNT available. TMP. It contains temporary files, usually saved there by applications that are running. Non-privileged users may also store files there temporarily. Note that files stored in this directory may be deleted at any time without prior notice. And proc is a virtual directory. It contains information about your computer hardware, such as information about your CPU, RAM, memory, or kernel. The files and directories are generated when your computer starts or on the fly as your system is running and things change. For example, if I want to see information about the CPU, I can run cat/proc CPU info. And it has displayed information about the CPU. Or if I want to see information about the memory, cat/proc meminfo. This is the information about the memory. Sys contains information about devices, drivers, and some kernel features, and SRV contains data for servers. You use neither sys nor SRV directly. And the run directory is fairly new and different distributions use it in different ways. It's a temporary file system which runs in RAM, so its contents will vanish when the system reboots. This directory is used only by processes. And USR was the initial user's home directory in the early days of Unix. However, these days /home took its place, and USR contains many other subdirectories with binary files, shared libraries, and so on. On some distributions, like CentOS, many commands are saved in /usr/bin or in usr sbin instead of /bin and /sbin. On both Ubuntu and CentOS, /bin and /sbin are symlinks to /usrbin and /usr/sbin respectively. And finally, var. It contains variable length files such as logs, which are files that register events that happen on the system. Let's display the contents of a log file. cat/var/log auth.log. This file contains information about authentication tries. It's possible that your Linux distribution may have more or less directories at its root because there are slight differences between distributions. However, we've discussed here the most important and used ones. In the next lecture, we'll be talking about absolute and relative paths and walking through the file system. The basic way to explore the Linux file system is to use the cd, pwd, and ls commands. cd stands for change directory and will take you to the directory you specify as argument. For example, cd /var/log will take me to the log directory that resides in var, which in turn resides in the root directory. If you get confused, just run pwd, which stands for print working directory, and it will tell you which directory you are in. The current directory is also part of the prompt. To see the contents of any directory, run ls and the directory as argument. If you run ls without any argument, it will display the contents of the current working directory. This is the contents of /var/log. To become proficient in working with the Linux file system, which by the way is extremely important for any effective system administrator, you need to deeply understand what is a path and how to use it. In my opinion, this is one of the most important concepts a beginner should learn. Unfortunately, many times it brings a lot of confusion. Take your time to exercise how to work with paths and do not go further until you master it. Let's see what is a path. A path is a unique location to a file or a directory in the file system of an operating system. In Linux, there are two types of path names: absolute and relative path names. An absolute path is defined by specifying the location of a file or directory from the root directory, which is /. It's a complete path and always starts with /. This is, for example, an absolute path because it starts with a /. To write an absolute path, start at the root directory and go deep into the file system, writing a / after every directory name. Linux uses forward slashes to separate directory names and does not use backslashes like Windows does. Let's see some examples of absolute paths. This is an absolute path. Another one. They are absolute because they start with a /. Use the tab key for auto-completion. This will help you save a lot of time and also prevent you from making mistakes. Or cd/home, student, and desktop, written with capital D. This is the desktop directory. It's similar to ~/desktop. It's the same. Remember that tilde means the user's home directory. So /home/student. And by the way, in Linux, the desktop directory is called desktop, written with a capital D, and is located in the user's home directory. I'm creating a new folder on the desktop using the graphical interface and then displaying it in the terminal. It was created. The folder is on my desktop and I'm displaying it using the ls command. It's there. Let's move on and see another absolute path. /var/log/boot.log. I'm displaying the last lines of a file as root. Let's go ahead and see what is a relative path. A relative path is defined as the path related to the current working directory. It begins at your current directory and never starts with a /. Before going on with the relative paths, let's understand the special meanings of single dot and double dot used in a relative path. Simply put, a simple dot represents the directory you are in, and two successive dots or double dot represents the parent directory. On a Linux system, these items are automatically created in every directory and can be seen by using the ls command with the -a option. -a means show hidden files as well, and any file or directory that starts with a dot is hidden. For example, ls-la. I have displayed the contents of the current working directory, my desktop, and we see there the current directory, the single dot, the parent directory, double dot, or tilde, this is tilde, the user's home directory, and folder 1, the directory I've just created. ls-a tilde, I'm listing the contents of tilde, the user's home directory. And we see there both the dot and double dot. Using a single or double dot, we can build the relative path to any file or directory from the current working directory. Let's try some examples. I'm moving to /etc directory. I've used an absolute path. I'm printing the current working directory by running pwd. And it's showing as being /etc. If I want to see the contents of a file named hosts in the current working directory, I'll simply run cat or other command used for displaying files and the name of the file, like cat hosts. This is a relative path that uses the current working directory as reference. It doesn't start with a /. Another way to use a relative path to the same file would be cat./hosts. It's the same. Note that I've used a dot character to represent the current working directory, which is the default anyway, and the / is the directory separator. In other words, what I'm saying is print at console the contents of the hosts file, which resides in the current working directory, in the single dot directory. The same command using an absolute path would be cat/etc/hosts. Next, I want to see the contents of cron.daily directory using a relative path, and the command is ls cron.daily. The same command using an absolute path would be ls/etc/cron.daily. Now, I want to display the logrotate file which resides in cron.daily using a relative path, and I'm running cat cron.daily, a / the directory separator, and the name of the file, logrotate. And the same command using an absolute path would be cat/etc cron.daily logrotate. This is an absolute path. Let's see some more difficult examples. I'm moving to my home directory using an absolute path. I could have moved to the same directory by running cd without any argument, or by running cd and tilde. In Linux, tilde represents the home directory of the current user. Keep this in mind because it's important. From that directory, I want to list the contents of the home directory using a relative path. As I said earlier, two successive dots or double dot represents the parent directory, which is /home. So to see its contents, I run ls and double dot. This is the contents of /home, the parent directory. Now, if I want to see the contents of the root directory, I run ls double dot /double dot. This is the contents of the root directory of /. I'm moving up 2 levels. And a really complicated one. Let's display the contents of logrotate, which resides in /etc/cron.daily using a relative path. So cat, this is the home directory, this is the / directory, etc, cron.daily, and the file, logrotate. You notice how the relative path has changed according to the current working directory. The absolute path to that directory always remains the same. This is the absolute path. Maybe you wonder if there's any difference between an absolute and a relative path, or when to use each of them. My answer is that there's no difference. When you have to do something like remove a file or create a new directory, it doesn't matter if you are using an absolute or a relative path. It's more like a matter of convenience. If you are already in /etc cron.daily, it's more convenient to refer to log rotate using a relative path than an absolute one. It's easier to refer to the file this way than this way. On the other hand, an absolute path is more reliable than a relative one. I cannot say move to cron.daily directory by typing cd cron.daily. This is a mistake. This path is a correct one only if the current directory is /etc. If the user is in any other directory, that path will be wrong. It's correct only if the user is in the /etc directory. Another nice command you can use to get used to paths is tree. Tree is a recursive directory listing tool that helps you see easier and clearer the parent and children directories. Unfortunately, tree is not installed by default on Ubuntu. Let's install it quickly. Sudo apt install tree. It was successfully installed. If you run it with no arguments, it will display the contents of the working directory recursively, showing subdirectories and files in tree-like format. When a directory is given as argument, tree lists all the files and directories found in that given directory. Tree/etc. It's listing all the files and directories that reside in /etc. Upon completion of listing all files and directories, tree returns the total number of files and directories listed. Some useful options are -d to print out only the directories and -f to print out the absolute path for each file and directory. It's printing only the directories. It's printing only the directories and an absolute path, and it's printing both the files and directories using an absolute path. At the end, I want to stress again the importance of relative and absolute paths. Practice as much as possible and don't go ahead with the course without a very good understanding of how to use paths in Linux. Let's dive deeper into the ls command, which is probably the most used command in Linux. As I'm sure you already know, ls is used to list the contents of a directory together with lots of other information about files and subdirectories. Even though ls is a common command, it's a complex one with plenty of options. Read its help or its man page if you are not sure what a specific option does. The syntax of the ls command is as follows: ls, option, and file. As option and file are between brackets, they are optional. Let's see some practical examples. If I simply run ls with no options or arguments, it will print the contents of the current working directory at the terminal. The files are listed in alphabetical order. To list the files in a specific directory, pass the path to that directory as argument to the ls command. And if you want to have your listing produced in a single column, use the -1 option. 1 means one file per line. And you can specify as many arguments you want. In this example, ls will display the contents of /etc, /var, and the current working directory, which is by convention a single dot. The real power of the ls command comes from its options. Let's take a look at the most frequently used options. -l will display the output in a long listing format which means lacks of information about files and directories. This is the current working directory, and this is the contents of /etc in long listing format. By the way, if you want to see information about a directory like /etc and not about its contents, then use the -d option. It's displaying information about the etc directory and not about its contents. Let's return to the output of ls-l and let me explain to you what you see. The first character indicates the file type. A hyphen as the first character indicates a normal file. D indicates a directory, and L indicates a symbolic link, which is sort of a shortcut. The 9 characters that follow indicate the file permissions for the owner, the group owner, and the others. Then comes the number of hard links, the owner, and the group owner of the file. The next field is the size, and finally the modification time and the file name. We'll dive deeper into each concept like links, file types, and so on in the next lectures. For the moment, it's enough if you know what each field means. When you run ls, it's common to group together more options in order to get the desired output. For example, adding the age option, ls will show the file size in human readable format. Take a look at this column. It's in human readable format. By default, the ls command will not show hidden files. In Linux, a hidden file or directory is any file or directory whose name begins with a dot. To display all files, including the hidden ones, use the A option. These are hidden files, and this is a hidden directory. They all begin with a dot. Another useful option is capital S, which sorts the files by size, and the largest file will come first. Files are sorted by size. I'm adding the age option to see the size in human readable format. This is the largest file in /etc. Note that ls does not display the real size of a directory, as you'd expect. It displays only the size of the inode structure. To see the size of a directory, use the du command instead. Du comes from disk usage. In this example, ls command says that the etc directory has only 12 kilobytes, but this is not the size of all its contents. To see its size, run du -sh and the path to the directory. This is its real size. By the way, in /etc, there are some files that cannot be read by a non-privileged user, and that's why I've got these permission denied errors. Run the command as root to get rid of them and see the total space occupied. So sudo and the command will run as root. There's no error, and this is its size. To sort by extension, use the -x option written in uppercase. Files are sorted by extension. And if you want to omit certain files from the listing, use the -hide option. If you don't want to see the files which end in .conf in the listing, you can run this command. ls -hide equals star.conf and /etc. The star means any string of characters, and all those files that end in .conf will be omitted from the listing. There's no file that ends in .conf. With the -r option, you can list directories recursively. Recursively means that ls works its way through the entire directory tree below the starting directory and lists the files in each subdirectory. I'm listing the contents of /etc recursively. At the end, let me tell you something that will definitely surprise you. Up until now in the course, we've never actually run the original ls command. If you run type ls, you'll see that there's an alias called ls to ls ---- color equals auto. The ---- color equals auto is the option that provides the different colors for the different file types in the listing. That's why when you run ls-l, you see directories in blue, regular files in black, symlinks in cyan, or device files in yellow on a black background. If you want to run the original ls command without adding ---- color equals auto, run \ls and you'll see everything displayed in black. The / character cancels the alias. Let's go ahead and talk about file timestamps. Every file on Linux has 3 different timestamps: the access timestamp, or A-time, the modified timestamp, or M-time, and the changed timestamp, or C-time. Linux timestamps hold an integer number rather than a date and time. This number is the number of seconds since the unique epoch, which was midnight on January 1st, 1970 UTC. When Linux needs to display the date, it translates that number of seconds into a date and time. This makes it easier for humans to understand. To view these timestamps, use the stat command or ls with options. The stat command is showing statistics about the file, including the timestamps. You can see the access time, the modification time, and the changed time. ext4, which is the default file system on most Linux distributions, also allocates space for a file creation timestamp in its internal file system structures. But in most cases, this hasn't been implemented yet. In this example, file creation or birth hasn't been implemented yet. That's why we see a hyphen instead. Let's discuss what these timestamps mean. The access time, or A-time, is the last time the file was read. This means the time when someone used a program to display the contents of the file. It doesn't matter if the file contents were changed or not. The modification timestamp, or M-time, signifies the last time the contents of the file was modified. If someone used a text editor and changed something inside the file, M-time was updated. And finally, the change time, or C-time, is the time when some metadata related to the file, not the file contents, was changed. For example, changing the file's permissions or the file's owner will update the changed time. To see the timestamps with the ls command, run ls-l or ls-lt if you want to see the modification time, ls-lu to see the access time, and ls-lc to see the change time. Sometimes the ls-l is not displaying the timestamp with a maximum precision. In this example, we only know the month, the day, the hour, and the minute when the file was last modified. To see the entire timestamp that was saved, this means including the year and the second, use the --full -time option, like this: ls-l, --full -time, and etc, or the directory. And we are seeing the entire timestamp. Let's talk about changing the file timestamp. This is useful when you want a backup program to include or exclude some files, or when you simply do not want other users to know that you've read or modified the file. You can change the timestamp on a file using the touch command. The touch command is also used to create an empty file. So, if the file, which is the argument of the touch command, does not exist, touch will create it. But if it exists, touch will update the file timestamps to the computer's current time. This is the contents of the current directory, which is the user's home directory. And if I run touch linux.txt, it will create the file since the file does not already exist. The file is there. Let's see the modification time. And stat linux.txt. These are the timestamps of the file. By the way, in Linux it's not recommended to use spaces or other special characters in file names. Separate multiple words with an underscore or a hyphen. But if for some reason you want to include a white space in the file name, then enclose the file name in a pair of double quotes, like this. The file name contains a white space. Now if I run touch linux.txt again, it will update all three timestamps of the file to the current time. Touch linux.txt and stat linux.txt. These are the new timestamps. Take a look, they are updated. (14:29) and now it's 14:30. If you want to change only the access time to the current time, use the -a option. So touch -a linux.txt and stat linux.txt. Note that the access time was updated to the current time. The changed time was also updated because metadata information of the file, like a-time, was changed. This is normal behavior. To change the modification timestamp, you can use the -m option, touch -m and the file. And stat linux.txt. See how both mtime and change time were modified. If you want to set the access time or modification time to a specific time, not the system current time, you can use the -t option and a date time. Let's change the modification time to a date in the past. Touch -m and the date. Let's say 2018, 12 the month, 30 the day, the hour, the minute, and that the second. And the file. The format of the new timestamp is year, month, day, hour, and that seconds. Sorry, I've forgotten the -t option. This is very important. And the modification time was changed. If you want to change simultaneously both access and modification time, use the -d option like this. Touch -d, between double quotes a date, in this format, and the file. Both a-time and m-time were changed. Note that -d and -t options accept different time date formats. You can also use the -r option if you want to set the timestamps of one file to the timestamp values of another one. For example, I'm creating a new file, ubuntu.txt. These are its timestamps, and I'm setting the timestamps of linux.txt to the timestamps of ubuntu.txt. So touch linux.txt -r ubuntu.txt. Ubuntu.txt is the reference file, and statlinux.txt. They have the same timestamps. Note that it's not possible to modify only the changed time to a specific timestamp. But I'll tell you a trick. If you want to modify only the changed time to a specific time, then you set the system date and time to the desired changed time, run the command touch and the name of the file to change all the timestamps to the system current time, and then change back the access and modification times to the initial values. Changed time will remain at the desired value. You can do this as homework. Use the date command to both display the current date and time and set the system date and time. This is the date and time using the local time zone, East European time, and date -u is displaying the date and time using the coordinated universal time or UTC. Check Xmam page to see the format of the new date if you want to change it. Let's talk about sorting the output of the ls command by timestamp. This is a common task. By default, the ls-l command is showing the modification time, this is the modification time for each file, and sorting the output by name. And the ls command is listing the files in alphabetical order. If you want to sort by modification time, add the -t option. It will display the output sorted by modification time, newest files first. They are sorted by modification time. If to -lt option you add the -u option, then it will sort by and show access time. It's sorting by and showing access time. The same option -u with L will show the access time and sort the files by name. This is the access time and the files are sorted by name in alphabetical order. If you want to reverse the order of sorting, add the -r or -- reverse option like this. -r or -- reverse. It's showing and sorting by access time in reverse order. Note that you can group -r with other options, or use the long option format instead. In Linux, the file is a central key concept. When administering a Linux system, you have to deal with lots of files, and knowing their type is really important. In this lecture, we'll see what type of files are available. Linux determines the type of a file via a code in the file header. It doesn't depend on the file extension. In fact, it's quite common in Linux for files to not have any extension at all. These are only a few examples of important system files that do not have an extension. The shadow file, which stores the user's passwords, the group file, which stores the groups, and many more. They have no extension. Also, all executable files or commands do not have extensions. These executable files have no extension. In Windows, they would be .exe files. This is one of the differences between Linux and Windows. In Linux, file extensions do not matter so much. They are mostly for humans to find out visually what a specific file could represent. When you see a file name which ends in .log, then it's probably a log file, or a file which ends in .conf, it's probably a configuration file. This is probably a configuration file because it ends in .conf. I want to give you just one example that shows that extension doesn't matter. I have this image on my desktop and I run file and the path to the file to see its type. So file, desktop, linux.jpg. And it's a JPEG file. Now I'll rename the file to change its extension to PNG. The source file, linux.jpg, and the destination. This is how you rename a file in Linux. We'll have a dedicated lecture on this. Now it's a .png file. If I run the file command again, we'll see that the file type remains the same even though I've changed its extension. File and the path to the file. It's of type JPEG, image data. It's not a PNG file. Linux determines the file type via a piece of information in the file header. However, graphical applications might require the file to have a specific extension in order to open it. If you have a text file and change its extension to JPEG, then you cannot open that file anymore by double-clicking with the mouse on it. If I rename the file again and write .txt and try to open the file using the graphical environment, using a graphical application, it won't work. So extensions are useful only for graphical applications. It still contains JPEG image data. Let's take a closer look at the output of ls-l command, which is one way of finding what type a specific file is. This is indicated by the first character. If you see a hyphen, it means that's a regular file. -d indicates a directory, which is a special type of file. I'm listing the contents of /etc. -l indicates a symbolic link, which is like a shortcut, and other possible characters and file types are B, which means a block device. For example, ls-l/dev/sda1. This is a block device. And C indicates a char device. All of these files are of type char device. Device files represent logical hardware devices like a disk, a partition, or a serial console port. If you see an S, the file is of type socket. This is a socket. S on the first position. This is used by processes to communicate and has nothing to do with the socket term used in TCP/IP networking. And the last possible option for the first character is a P, which indicates a named pipe. Let's find the named pipe. This is a named pipe. The first character is P. Named pipes aren't used all that often. It's possible that you won't use them explicitly at all. However, a named pipe, like a socket, provides an easy way for the processes to communicate. Using named pipes, you could send the output from one command to another and end up with only the data you want to see without selecting and formatting the entire output. Another way to classify a file is to run ls with the capital F option. This will add a symbol after the file name according to its type. A / indicates a directory. No symbol added indicates a regular non-executable file. An @ sign indicates a symlink. And an equal sign indicates a socket. And a pipe, a vertical bar, indicates a named pipe. And if you find all of this confusing, you can run the file command to find out the type of any file. Note that none of the methods shown in this lecture determine the file type based on the file name extension. Let's see some examples with the file command. This is a directory. This is a regular file, an ASCII text file. By the way, -f will add a star, an asterisk, to executable files. Let's see a symlink. This is a symlink, so file /etc vtrgb, symbolic link, and file /run and an asterisk will show information about all the files in a directory. This is a socket, this is an empty file, this is a named pipe, this is a directory with the sticky bit set, and so on. The entire configuration of the Linux system is saved in text files. User accounts and their passwords, groups, the network configuration, the security policy, the configuration of any network service like a web FTP or an email server are all saved in text files. In this lecture, I'm going to show you different ways to read text files on a Linux system. Of course, there's always a graphical text editor if you have installed a graphical interface. For example, both on Ubuntu and CentOS, we have the gedit editor available. To open it, click on Show Applications, search for Editor, and open the text editor. This is gedit. You can edit any file like you do with the Windows Notepad. However, since most of the administration work is done in the terminal, I want to show you what commands are available for viewing text files. The cat command is probably the most used one when reading files in Linux. It just displays the contents of the file in the terminal window and provides the prompt again. Let's see an example. cat/var log auth.log. This is a log file, and it has displayed the file contents on the screen. The syntax of the cat command is cat and the name of the file you want to see using the correct absolute or relative path. If you want, you can give more files as arguments, and cat will display all of them in the terminal. Let's display two files. Cat etc password etc group. It has displayed both files. This is the first one and the second file. When running the cat command, you don't usually specify any option. The single option I've sometimes used was -n to print out the number of the line as well. Cat -n etc password, and the line number was printed as well. Please note that cat shows the entire file at once. It's not interactive, and if the file is too long, the contents scroll off or exceed the screen. Like in this example, we don't see the entire file on the screen. For this reason, cat is the tool of choice when you want to display small files, like for example etc hosts. This is a small file and its entire contents fit the screen. Cat is short for word concatenate, so besides displaying the contents on the screen, it's also concatenating more files into a single one. Let's see how it works. I'm concatenating two files into a single one. Cat, the first file, etc hosts, the second file, etc host.conf, the greater than sign, and the resulting file. Let's see my host.txt. This was the first file, the second file, and the resulting file. The resulting file that was created contains the contents of both files. Let's take a look at the command that has concatenated the file again. This one. The greater than sign means output redirection and is used to redirect the output of the command to a file instead of printing it on the screen. So instead of printing the contents of the file on the screen, it redirects it to a new file which is created if it doesn't exist or overwritten if it already exists. In this case, the file was created. We'll have an entire lecture on command redirection later in this section. If the output of a text file exceeds the terminal window, you probably want to use the more or less commands instead of cat. Both tools are known as pagers and will take the input from a file and send it to the terminal one page at a time. Less extends the capabilities of more and is probably the most advanced and used reading tool that Linux provides. To view the contents of a file with less, you write less and the name of the file using a correct path, like say less/var log the message. This is the contents of the file. I've already discussed some rules and options when we've talked about man pages in the previous section of the course. When you run man and the command to see its man page, less is launched by default. For example, man rm, and the contents of the man page is displayed using less. Let's see the most important and used options again. While you are in a file, you can get additional help by typing the letter H. To exit the file, type Q. I'm opening it again. While in the file, you can use the arrow keys to move a line up or down. To forward one window, press on Ctrl and F or on the space key. I'm moving one window forward. And if you want to move backwards a screen or a window, you press Ctrl B. I'm moving backwards. I'm already at the beginning of the file. To go to the very beginning of the file, type lowercase g, while to go to the very end, type uppercase G. I'm at the end. Sometimes you want to search in the current file for a specific string. Let's say I want to search for the root string in this file. First, I'm going to the beginning of the file by pressing G. I'm at the beginning. And to search for the string, I write a / and the string I want to search for, root. And I'm hitting enter. Any matches in the current file will be highlighted. You can then navigate between matches with N, which means next occurrence, next, or Shift N or uppercase N, which means the previous occurrence. So it searches backwards. I'm pressing capital N. This is the first occurrence. When you search by using a / and the searched term, it searches forward. But if you are, for example, at the end of the file and want to search backwards, then you type a question mark instead of a /. I'm going to the end of the file by pressing uppercase G, and I'm searching for the word kernel backwards. I'm hitting enter. It has searched backwards for the kernel word and it found more matches. Press on N and uppercase N to go from match to match. Backwards and forward. These were the most important options of less. Another useful command used for viewing files is tail. Using tail, you can view the last lines of a file, and by default it shows the last 10 lines. Tail etc password. These are the last 10 lines of the file, so the last 10 users. If it seems too basic, imagine that you are most of the time interested in the last events that took place. For example, the command I've just executed has shown the last 10 created users. Tail has several options that can be used to get the desired output. If you want to read a custom number of lines of a file, use -n and the number. For example, I want to see the last two groups that were created, tail -n2 and the path to the file, etc group. this is where the groups are saved. And these are the two groups that were created. Or if I want to read the last lines starting with a specific line number, then I can use a command like this: tail -n plus 20 and the path to the file. For example, var log syslog. It will display the last lines of the file starting with the line number 20. So from line 20 to the end. Tail is really useful for reading a file in real time, like when you want to view the last n lines of a log file for important system messages. You use tail to watch log files as they are updated. Using the -f option, tail automatically brings new messages from an open file to the screen in real time. For example, to actively watch as users log in and out, I'll run the following command: tail -f and the path to the file where authentication tries are saved. /var log auth.log. These are the last 10 lines of the file, and the contents of the file will be updated in real time. And in another terminal, I will log in into a shell as root. So sudo su. I'm entering the wrong password on purpose. See how tail has updated the file in real time. We can see the authentication failure message. The user student couldn't become root. Now I'll authenticate successfully. And this is the message: session opened for user root by student. Student to root. When you are finished with tail, press Ctrl and C. The last command I'm gonna show you is head. It's the complementary of tail command, and as the name implies, brings the top n number of lines from a given file. Head is used to display the beginning of a file. Head etc password. By default, it reads the first 10 lines of a file, so the previous command has printed out the first 10 users. You can change the number of lines displayed by specifying -n and the number, or simply the number of lines you want to see. Head -n 3 /etc group. These are the first 3 groups. Or head -7 /etc group. The first 7 groups. And at the end, I'll introduce you to another Linux command which has nothing to do with viewing files, but could be very useful. If you want to run a command repeatedly, displaying its output and error, you use the watch command. It allows you to watch the program output change over time. I'm running ls repeatedly. Watch ls. This is the contents of the current working directory, the user's home directory. By default, the ls command is run every 2 seconds, and watch will run until interrupted. To interrupt it, hold Ctrl and press C. So Ctrl and C. Two interesting options are -d to highlight the differences between successive updates, and -n and the number to specify the update interval. I'm running the ls-l command every 3 seconds, highlighting the differences. So watch -n3 -d ls -l. And in another terminal, I'm creating a file in the same directory. Touch abc.txt. See how it has highlighted the differences between updates. In the last example, I want to see how packets are sent and received by executing the ifconfig repeatedly. Watch -n1 -d ifconfig. I'm closing this terminal. You can generate some network traffic to see it clearer. I'm opening the Firefox browser and visit some websites. Okay, see the differences. See how the number of received and sent packets is updated. In this lecture, I'm gonna show you how to create new files and directories. To create a new file in Linux, you have to use the touch command. We've already discussed it in a previous lecture, so now we'll just recap it quickly. The touch command takes as argument one or more files. If those files already exist, touch will update the file's timestamps to the current system time. But if the files do not exist, then touch will create them. Touch report.txt. Touch logs. Since the files didn't exist, touch has created them. If I run it again with the same files as arguments, then touch will set the file's timestamps to the current time. Let's see the timestamps. These are the file's timestamps. And I'm running the touch command again. Touch, the first file, and the second one. And stat report.txt and logs. See how it updated the A time, M time, and C time. Note that you can change A time and M time individually as well. See the previous lecture where I've gone deeper into this if you feel the need. And if you want to create a new file that contains a white space in its name, then put the whole name between double quotes. So touch in user's home directory, it's the current directory anyway, and between double quotes, learning Linux. This is the name of the file. It contains more white spaces. However, Linux is not recommended to have file names that contain white spaces. Use an underscore instead if you wish a more readable name. So a more appropriate name would be something like this. Much better. Also remember that in Linux, case matters. So a file called report.txt, which starts with a capital R, is a complete new file. Or touch report.txt. There are 3 files called report.txt in the current directory. Only the capitalization differs. It's important to note that the user executing this command must have enough permissions to create the file in the parent directory, or he will get a permission denied error. For example, I'm logged in as student, a non-privileged user, and if I try touch /etc abc, I've got a permission denied error. This non-privileged user is not allowed to create the file called abc in /etc. Let's move on and see how to create new directories using the mkdir command. Mkdir comes from make directory. This is the command, and its syntax is mkdir, some options, and some directories. Let's see an example. In the current working directory, I'm gonna create a directory called dir1. mkdir dir1. This is the new directory. In case you want mkdir to display some details about the operation it's performing, then add the -v option. -v comes from verbose. mkdir -v dir2. It has displayed this message and created the directory. And if you want to create more directories in one command, then give all directories you want to create as arguments. So mkdir dir3 dir1 /dir10, it means it will create a new directory called dir10 inside dir1. and /tmp, tmp_dir, the third directory. In this example, I've created 3 directories at once. dir3, dir10 inside dir1, and another directory inside /tmp. Now, let's suppose I want to create a complete directory structure, and to do that I run mkdir, let's say first, second, third. So I want to create a new directory called first in the current directory, inside first another directory called second, and inside it a directory called third. Note that none of these directories exists. If I'm hitting enter, I'm getting an error. Cannot create directory, no such file or directory. Maybe it's weird, but mkdir wanted to create the directories from right to left. So when it wanted to create the directory called third, this one, it noticed that its parent directory called second didn't exist. To solve this issue, just add the -p option, which comes from parents, and it will make the parent directories as needed. I'm adding the -p option between the command name and its arguments. And it has created all 3 directories. See how they look like. -p option is also good when the directory already exists and you don't want an error. In this example, there's already a directory called dir1 in the current working directory. I've just created it. If I try to make it again, I'll get an error. mkdir dir1. Cannot create directory, dir1, file exists. Remember that a directory is a special type of file. But if I add the -p option, there will be no error. Okay, that's all about creating files and directories. Thank you. Let's move on and see how to copy files and directories using the cp command, which stands for copy. cp has 3 principal modes of operation depending on the number and the type of arguments passed. If the command has 2 arguments of type files, it copies the contents of the first file to the second file. If the second file does not exist, cp will create it. But if it already exists, cp will overwrite the destination file. I'm copying the password file from /etc directory to another file in the current working directory. So cp /etc password /users.txt. The destination file users.txt doesn't exist, so it will create it. This is the file in the current working directory. Now I'm trying to copy another file to the same destination. Copy etc group users.txt and cat users.txt. There's another content. The user.txt file already exists, so it has overwritten the file without prompting. To show files that are being copied, pass the -v option to the cp command. This brings the files and folders that are being copied to standard output. I'm running the last command again, this time passing the -v option. As usual, -v comes from verbose. And if you wanted to prompt before overwriting, add the -i option. Let's run it again without any option. The users.txt file already exists and it's not prompting. This is the default behavior. But if I add -i, it will prompt. For beginners, what is the most important and difficult at the same time is to use the correct path for both the source and the destination. Always use the tab key for autocompletion. The second mode of operation is when CP has one or more arguments of type file, which is the source, and the last argument of type directory, which is the destination. In this case, it copies the source files to the destination directory, creating any files that do not already exist in the destination. Let's see an example. cp learning_linux logs users and the destination. The destination will be the directory called first. It will copy these three files to the destination directory. Add the -i option, which comes from interactive, if you want it to prompt before overwriting the destination file if it already exists. It's not prompting, and now it will prompt. And the third and the last mode of operation is when all arguments are of type directory. In this case, cp copies all files in the source directory to the destination directory, creating any files or directories needed. This requires -r, an option that indicates the recursive copying of directories. Let's see an example. Sudo cp-r /etc ~desktop. This command will be run as root because I'll copy the etc directory to my desktop. A non-privileged user is not allowed to read some of the files in the etc directory. Look how a directory called etc has appeared on my desktop. And of course, without the -r option, I would have got an error. It's not allowed to copy a directory without specifying this option. Let me show you one last example. Consider this file called users.txt, which belongs to the user student. Student is the file's owner, and another user that has read access wants to copy that file. I'll copy the file as root, so sudo cp users.txt u.txt ls-l. This is the new file. What do you notice? When copying a file, the user that runs the cp command becomes the file's owner, and that's not good in some cases. To preserve file attributes, permissions, group, and user ownership, pass the -p option, which stands for preserve. By default, the permissions, ownership, and timestamps are not preserved. I'll copy that file again, this time adding the -p option. Let's say u1 and cp-p. Pay attention to these three files. The permissions, owner, and timestamps were preserved for u1.txt because I've used the -p option. In this video, I'll be showing you how to move and rename files and directories in Linux. We'll talk about the mv command. The mv command is a command line utility that moves one or more files or directories from one place to another. This command has two distinct functions. It moves files and directories, or it renames files and directories. Yes, there's no mistake. You can use mv both for moving and for renaming files. Before starting with an example, I will delete all the files and directories that I've created in the last lecture in the user's home directory. Now I'm creating a new directory tree structure for this lab. mkdir -pdir1 and dir2 inside. And I'll create a file in each directory. So tax dir1 a.txt, dir1 dir2 b mv.txt and c.txt in the current working directory. Let's move a file into a directory. I'm moving b.txt, which is in dir2, to dir1. So mv, the path to the file, dir1, dir2, b.txt, and the destination path, the destination directory, dir1. The file was moved. Let's see how to move multiple files into a directory. For this, I'm gonna specify all the files I want to move as arguments, and the last argument will be the destination directory. mv c.txt in the current working directory, dir1 a.txt, dir1 b.txt, and the destination will be dir1 dir2. So in fact, I'm moving all these three files into a directory called dir2, into this one. Sorry, 3, dir1. The files were moved. You can also use a pattern matching like this. mv dir1 dir2 star.txt dir1. I'm moving all the files which end in .txt from dir2 to dir1. And if you want to move a directory, you move it as you would any other file. I'm creating a new directory, mkdir, dir1, dir2, dir3. And I'm moving dir3 into dir1. So mv, the source, dir1, dir2, dir3, and the destination. dir3 was moved. Now it's in dir1. Now let's see what happens if the destination file already exists. I'm creating a new file called a.txt in dir2. Touch dir1, dir2, a.txt. This is a new file. And I'll move it to dir1. So mv dir1, dir2, a.txt, dir1. a.txt will be moved from dir2 to dir1. And the file was moved and the destination was overwritten without prompting. To prompt before overwriting a file, the -i option can be used. -i comes from interactive. I'm creating a file called a.txt in dir2 again. And I'm moving it. And it's prompting. I'm pressing Ctrl+C. I'm aborting the operation. To prevent an existing file from being overwritten, use the -n option. This causes the mv command to ignore anything that would overwrite an existing file. I'm creating a file called a.txt again. And now I'm running mv -n dir1, dir2, a.txt, dir1. It didn't move the file because the destination already existed and it would have overwritten the file. Another useful option is -u or --update. When using this option, it will move only when the source file is newer than the destination file or when the destination file is missing. This guarantees that only newer files will be moved. This is especially useful in shell scripts. In dir2, I'll create a new file called b.txt. Touch dir1, dir2, b.txt. And mv -u, dir1, b.txt, dir1, dir2. I want to move the file called b.txt from dir1 to dir2. And there's already a file called b.txt in dir2. I've just created it. What do you think? Has it moved the file? Let's check it. And b.txt was not moved. It's still in dir1. That's because b.txt it's not newer than the destination. As I said at the beginning of this lecture, MV can be used to both move and rename files. If the source file is in the same directory as the destination file, then MV will rename it. I'm renaming a.txt from dir1 to abc.txt. So MV dir1 a.txt and the destination dir1 abc.txt. The file will be renamed. The source and the destination directory is the same. It was renamed. And you can rename a directory in the same way. I have renamed dir1 to dir10. And the last example, you can even move the file to a different directory and rename it at the same time. I'm moving c.txt from dir10 to dir2, renaming it at the same time. MV, the source, dir10 and c.txt, and the destination, dir10, dir2, and the new name of the file. Let's say cc.txt. The file was moved and renamed at the same time. That's all about the mv command. Thank you. Now that you know how to create files and directories, how to copy, move, and rename them, it's time to see how to remove them. In Linux, to remove files or directories from the command line, use the rm command. Be extra careful when removing files or directories, because once the file is deleted with the rm command, it cannot be easily recovered. There isn't such a concept as a recycle bin or trash for the files that were removed from the command line. To remove one or more files, give them as arguments to the rm command. I'll remove this file, abc.txt, and a.txt from dir2. So rm, the first file, I'm using a correct relative path, dir10 abc.txt, and the second file, dir10 dir2 a.txt. Always use the tab key for auto-completion. I'm doing it myself as well. Note that the files were removed immediately without prompting. To prompt for confirmation when removing a file, use the -i option. It's the same option we've seen at cp and mv commands and comes from interactive. It will cause rm to ask for confirmation. If confirmation is given, the file is removed. And if it's not given, the file removal is skipped. Let's try to remove b.txt from dir2 using the -i option. rm -i and the file, dir10 dir2 b.txt. And it's asking for my confirmation, and I want to remove it. To show more information when removing a file, add the -v option, which comes from verbose. rm -v dir10 b.txt. I'm removing this one. And it has displayed a message about what it did. Let's see how to remove directories. If you try to remove a directory as you would a file, you'll get an error. rm dir10. Cannot remove dir10 is a directory. To remove directories, use the -r or ---- recursive option to make removal recursive. So rm -r dir10. Sorry, -r, not -f. If you try to remove a write-protected file with rm, by default, it will prompt for a confirmation. As root, I'm creating a new file in the current working directory. This file belongs to root, but the student user is allowed to remove it because it's in its home directory. rm a.txt. and it's prompting for my confirmation. Remove write protected regular empty file, yes or no. And it was removed. Just imagine that you have to remove hundreds of files from a directory and you have to confirm each removal. It's impractical. To force removal and not receive a prompt, press the -F option. -F stands for force, like rm -rf music and pictures. I'm removing two directories that are in my current working directory, and they were removed. Sometimes it's common to combine R and F together to remove both files and directories without a confirmation, like I did in the last example. I'd like to say a little bit more about this command. If you run it as root and make a mistake, then your files are gone. You cannot recover them. As I said before, there isn't such a thing as recycle bin, a trash, or the undo remove command. To stay in the safe zone, my advice for you is pay special attention when removing files as root and always, but always use tab for auto-completion. Let me show you an example of why you should do that. Let's suppose that as root, you want to remove an ordinary file from the user's home directory. I'm creating a file and I want to remove it as root. So sudo rm -rf and the path to the file. So /home student a.txt. I'm using an absolute path. Maybe the root user is not in the user's home directory, so in /home/student. Of course, I have used the tab key for auto-completion. But suppose you say that it's not necessary to use tab for auto-completion because you can write quite fast anyway. And by mistake, you write a white space after /home. Like this. There is such a probability, especially if you do it often enough. What will happen is that the rm command will consider that it has two arguments, /home, the first directory, and then another file called a.txt, which resides in a directory called student, and will try to remove them both. Such a mistake is disastrous because it will remove the entire /home directory. This one. Such a mistake could be avoided by always using the tab key. If you, by mistake, type a white space somewhere in the path, then tab will not complete the path. I'm pressing tab and it's not completing the path. There's a mistake. My second advice is to pay special attention when using pattern matches and wildcards like asterisks, ducks, or question marks. This is also applicable to other possible destructive commands, not only rm. Before running a command like rm star.txt, execute echo and the pattern to see exactly what are the files that will be matched. Sometimes these patterns expand in names you don't expect to. So before executing this command, execute echo and the pattern to see which files will be matched. And it's okay. There's a file called a.txt, a single file. At the end, I'll tell you something really important. The rm command does not actually delete a file. Instead, it unlinks it, meaning the data is still on disk. The space on disk occupied by the deleted file is marked as being free and can be used by other file or process. Now, depending on different factors, there are professional solutions that make the recovery of the deleted files possible. This is available to any other operating system, including Windows, Mac, or Android. So, if you remove a file, you can't be 100% sure that no one will ever recover it. This is, for example, just a free tool that can recover deleted files. You can try it on Windows. What you can do is use the shred command instead. Shred overwrites a file to hide its contents many times before removing. Let's see an example. I'm copying the password file from /etc to the current directory. And shred -vu -n 100 and the file. Great. -v means verbose or showing the process, and u means removing the files after overwriting. And -n and an integer number overwrites the file n times instead of the default, which is 3. The file was overwritten with random contents before removing. In my opinion, even though shred is good enough in the secure removal of files, if you want to keep your confidential data secure, you have to encrypt it. You cannot rely on simply deleting a file and suppose that no one could ever recover and access it. In this lecture, I'll be talking about pipes, which are one of the most useful command line features in Linux. Pipes are used in countless ways and are just about everywhere. The Unix and Linux design philosophy is to have many small utilities that perform very well just one dedicated function without needless functionality. In Linux, you write programs to do one thing and to do it well, and then you make them work together. Let's take a look at this image. Every command or program we run has 3 data streams connected to it. stdin or standard input, which represents data fed into the program or the data the program is working with. stdout or standard output, which is data printed by the program by default to the terminal, and stderr or standard error for error messages and also defaults to the terminal. Using the pipe symbol, which is a vertical bar, we can connect 2 or more commands at a time. This supports the initial Unix philosophy of chaining programs together to complete complex tasks. So a pipe lets us send the output of one command as input to another one. Piping and redirection are the means by which we may connect these streams, input, output, and error, among programs and files to direct data in interesting and useful ways. Let's take a look at this mechanism. I'm running ls -l capital S h /etc. The command has listed all files in the etc directory sorted by size in human readable. There are lots of files, and I finished up seeing only the last ones, the smallest files. The largest ones are at the beginning, and I have to scroll to see them. What I could do is connect the ls command with the head command. Using a pipe, I'll send the output of the first command, which is ls, as input to the second command, which is head, like this. Pipe, head. And we are seeing only the head, or the first 10 files of the output, and those are the largest ones. It's common and recommended to add a white space before and after the pipe symbol. But that's not, however, mandatory. This isn't an error. We can pipe together as many commands as we wish. In the next example, I'll filter and display only the 20th file of the output. It's just an example to see how it works. So head -n20, pipe, tail -n1. This is the 20th line of the output. Let's take a closer look. The output of the ls command becomes the input for head, which will display the first 20 lines. These first 20 lines, which are the output, are fed as input into the next command, which is tail, and the tail command will display only the last one, which is in fact the 20th line of the output. So the pipe takes the output from one command and uses it as input for another one. And the last example, I want to find out how many authentication failures took place. There isn't such a command in Linux, so I have to build my own using pipes. First, using cat, I'm displaying the entire file. Cat var log auth.log. This is the file where authentications are saved. This is the file. I can also add a -n to see the line numbers. Then, the output of the cat command will be given as input to another command called grep. Grep is a command line utility that searches for a string inside the file or a text and displays the lines containing the string. So pipe grep -a and the string I'm searching for. Authentication failure. And there are some matches. There are more lines that contain the string. These are all authentication failures. And finally, I want to see how many lines were found. The output of the grep command will be given to another command called wc, which counts how many lines were given. So pipe wc -l. And it returned 6. So there were 6 authentication failures saved in the log file. Let me tell you a few words about wc, which is short for word count. It brings new line, word, and byte counts for each file. wc etc password. There are 48 lines, 83 words, and 2825 characters in that file. This command is used to get different statistics. I've just found out that there are 48 accounts on the system. If you only want to see the line counts, then use option -l. wc -l etc group. There are 76 groups on the system. wc -w will display only the word counts and -c only the character counts. So wc -w, USR, share, dict, American English. This is a standard dictionary that you'll find on Ubuntu. And there's this number of words in this American English dictionary file. Let's see how many characters are in the file. And there are almost 1 million characters in the file. You can also use it with a pipe. Let's see how many users are logged in. Who is displaying? The logged in users. So who? Pipe wc -l. There's only one user logged in. One of the main purposes of piping is filtering. You use piping to filter the contents of a large file to find a particular string or a word. For example, note that when you use a pipe, you are not running a single command, but each command in the pipe starts. So, in this example, in this one, I've started 3 processes, each command starting a process: cat, grep, and wc. Take your time to exercise and deeply understand how pipes work, because this is a key concept in Linux and you'll find it everywhere. The pipe is one of the most used shell features. We'll continue our discussion and see how to redirect a command output to a file. A short recap. Every command you run has 3 data streams connected to it: stdin or standard input, stdout or standard output, and stdrr or standard error. Normally, when we run a command, we want to see the output on the screen in the terminal. This is convenient most of the time, but sometimes we may wish to save it to a file to keep it for the record, feed it into another program, or send it to someone else. To redirect the output of a command to a file, there's the output redirection operator, which is the greater than sign. It indicates to the command that we wish the output to be saved in a file instead of being printed on the screen. Let's see an example, and we'll start with a simple one. I'm running the ls command, which, as expected, has printed out the output on the screen. Now, I'm gonna use the output redirection to save it to a file. ls-l greater than ls.txt. Let's talk about what has happened. The greater than sign, which is the output redirection operator, has redirected the output to the file instead of printing it on the screen. See how a new file called ls.txt was created in the current working directory. And you notice that we didn't have to create the file before saving it. It has been created automatically. If I display its contents, I'll find there the output of the ls command. Now, let's see what will happen if we redirect it again to the same file. I'm redirecting the output of another command to the same file. I'll redirect the output of ifconfig. So ifconfig greater than and the name of the file. And I'm listing the file contents, cat ls.txt. And we notice something very important. The file was overwritten. The output of the first command is not there anymore. So you can draw a conclusion. When using the output redirection, we'll have two case scenarios. The file is created if it doesn't exist, or it is overwritten if it already exists. If we don't want to overwrite the file, we can instead append or add to the end of the file by using the double greater than operator. Let's run the same commands again. ls-l greater than, so output redirection, output.txt. And ifconfig double greater than output.txt. And cat output.txt. This is the file's contents. We see the output of both commands. The output of the second one was appended to the file. This is a big difference and it's important. Let's see another example. Who, double greater than operator, and users.txt. Of course, that file didn't exist. So, the double greater than operator creates the file if it doesn't exist, or appends to it if it already exists. Up until now in the course, I said many times that everything is a file in Linux or is treated as a file. To emphasize this concept, I'll show you how even the terminal is treated as a file. To see the file behind a terminal, run the tty command, tty. And we notice the file. This is the file. It's called 0 in pts directory, which resides in dev. I'm opening another terminal and I'll redirect the output of a command to the file that represents the other terminal. For example, ifconfig greater than /dev pts and 0. Very nice. We see how the output of the command was written to the file that represents the terminal and appeared in the first terminal. This is like a basic instant messaging, like this: hello, how are you? The string appeared in the other terminal. By the way, the echo command simply displays a line of text. Let's go ahead and talk about error redirection. The three streams attached to any Linux command actually have numbers associated with them. You see the numbers between parentheses. stderr, or standard error, is stream number 2, and we use these numbers to identify the streams. If we place a number before the greater than operator, then it will redirect that stream. If we don't use a number, like we have been doing so far, then it defaults to stream 1, which is standard output. Let's see some examples. I'm running a command which will return an error. Tail -n3 /etc shadow. Permission denied. A non-privileged user cannot see the file. To redirect the error message to a file, I'll use to, which is the ID of std_r, and the greater than operator. So to, greater than, and the file. Error.txt. It's not allowed to put any space between to and greater than. This is not allowed. And cat error.txt. We notice how the error was redirected to the file, which was also created because it didn't exist. In fact, the same rules from the output redirection apply to the error redirection as well. If you want to append to the file instead of overwriting it, use to and the double greater than sign operator. I'm executing the same command again, this time using to and double greater than sign. Like this. And cat error.txt. The error message was appended to the end of the file. This is another error. To double greater than error.txt. It was appended to the file. It's also possible to redirect both the normal output and the error messages of the same command. The same command could produce both normal output and errors. For example, tail -n2, etc password, and the second file, the second argument, etc shadow. It has printed the last two lines of the first file, these are the lines, but an error for the second file. It's not allowed to read the file. And I'm redirecting the output to a file called output.txt and the errors to error.txt. The files were created or overwritten. This is the output and this is the error. Okay, in the next example, I'll show you how to redirect both standard output and standard error to the same file. What I'll do is redirect standard output to a file and standard error to standard output. So I'm running the command again. This is the command. I'm redirecting the standard output to output.txt and standard error to standard output. $1. 1 being the ID of standard output. Cat output.txt. Note that the file contains both the output and the errors. One remark here. We've redirected to a stream by placing an ampersand in front of the stream number. Otherwise, it would have redirected to a file called 1. Now, the standard error was redirected to a file called 1. So this ampersand here is very important. You can also combine command redirection with pipes. Let's take a look at an example. Let's filter the line that contains the MAC address using a pipe. So ifconfig pipe grep ether. This is the MAC address, and I want to see the lines that contain the string ether. Great. We are seeing the output, and I'll save the output to a file. Greater than mac.txt. The output of the command was saved into a file instead of printed in the terminal. By the way, if you just want to get the MAC address without extra strings, you could try. I'm using a second pipe, cut -d, a space between double quotes, -f10. This is the MAC address, and I'm redirecting it to a file. By the way, I have introduced a new command which is cut. It cuts out sections from each line using a field delimiter, in this case a white space, and the section or the field number to cut. In this example, it was 10 because there are 10 white spaces till the field I wanted to cut, which was the MAC address. Just to get used to the cut command, you can try another simple example. Let's consider the password file. And I want to cut the first field, which represents the users, using a colon as a delimiter. So cut -d colon -f1, the first field, and the file. And we see only the users. Or I'll cut the user ID, which is the third field. Okay, let's go ahead. What can we do if at the same time we want to store and view the output of any command? If I use the redirection command, the output will be redirected to a file without displaying it in the terminal. For example, who greater than users.txt. I'm not seeing the output. Here comes into play the T command. Its name comes from the T-splitter used in plumbing. It basically breaks the output of a program so that it can be both displayed and saved in a file. Let's see an example. ifconfig pipe grep ether. This is displaying the output only on the screen. And this command is saving the output only to a file. I want a combination of these two commands. So instead of using the output redirection, I'll use another pipe and T. This command, with the help of the T command, writes the output both to the screen and to the file. I want you to see that a new file will be created. This is the output on the screen and cat m.txt. The same output was saved into the file. By default, the T command overwrites the file. You can instruct T to append to the file using the option -a as in the next example. Who pipe T -a m.txt and cat m.txt. The output was appended to the end of the file. And you can also write the output to multiple files. Let's see the kernel version. uname -r. This is the running kernel version. Pipe T -a mac.txt and kernel.txt. Oh, sorry, I've forgotten the command. So uname -r. uname -r and pipe T -a and the files. The output was displayed on the screen and appended to both files. Thanks, that's all about command redirection and piping. Linux is a file-centric operating system, and finding files and directories is a common administrative task. There are two commands used to find them: locate and find. In this video, we'll see how to use locate, and then we'll learn about find. Even though locate is a classical command from the early days of Unix, it's not by default installed on Ubuntu as it is on CentOS. To install it on Ubuntu, just run apt install mlocate as root. So sudo apt install mlocate. By the way, mlocate is the new implementation of locate. So at least on the latest versions of Ubuntu, when you run locate, it actually runs mlocate. Locate is faster than find because it doesn't search in the file system in real time. It uses a previously built database, whereas the find command searches in the real system through all the actual directories and files. On the other hand, the find command has more options available. The locate command searches by name and returns a list of path names containing that name in their path. The database used by locate should be updated periodically. It can be done automatically on a daily basis from cron, or you do it manually by running update db as root. Sudo update db. I'm updating the database used by locate. We'll talk about cron jobs later in the course. The database created by update db that will be searched by the locate command is in /var lib mlocate, and its name is mlocate.db. To see its path together with some statistics, like how many files and directories are indexed, run locate with the capital S option. So locate minus capital S. The basic usage of the command is locate and the name of the file or directory you want to find, like locate passwords. And it has returned a list with all path names that contain the passwords string. Pay attention that it searches for the string in the entire absolute path name. For example, if I search for, let's say, EA horse, okay, it will find all files and directories that have that string in their absolute path name. So it searches the whole path name. To search only the base name against the specified pattern, use the -b option. This is the opposite of the default option, which is -w or -- whole name. So locate -b EA horse. The selected file will not be found anymore. EA horse is not in its base name. Now it will find only files and directories that contain the string in their base name. When you search for a name, it will replace that name with name implicitly. So if you search for EA horse, it will replace that name with EA horse and will also find the files called seahorse. To disable this behavior and search for a file by the exact name, use a / before the name like this. Locate -b \name. / is a globbing character that disables the implicit replacement of name by name. So, of course, there's no such a file, but I'll try to find something like this. /EA horse. And it didn't find anything because there's no file or directory with that exact name. Let's see another example. Locate -b shadow. It found all files that have the string shadow in their base name, like rain shadow. But \shadow will find only the files with that exact name. Rain shadow is not there anymore. As I said earlier, the locate command does not search for a file in the file system, but in its own database, which should be updated periodically. I'm creating a new file with a unique name. Touch my file 123x. I suppose this name is unique. And I'm searching for it using locate. So locate and the name of the file. My file 123x. And as expected, the locate command didn't find anything because the new file doesn't exist in its database. I'm updating the database to reflect the latest changes in the file system. Sudo update db. And I'm searching again for the same file. And this time it found the file. If I remove the file and then search again for it, locate will still find it. I'm removing the file and I'm searching for it again. It was found even if the file was removed. To avoid this false positive result, the finding of a file that does not exist anymore, I can use the -e option or --existing so that it will check if the file really exists. So locate -e, my file 123x. And nothing was found. Note that when you update the mlocate database, it keeps timestamp information in the database. This allows mlocate to know if the contents of a directory changed without reading the contents again and makes updates to the database faster. Let's go ahead. Another useful option is -i, which will make locate ignore the case. Linux is a case-sensitive operating system and locate makes no distinction. So locate rain shadow. Nothing was found, but locate -i rain shadow will find a few files. It has ignored the case. And the last option we'll discuss is -r, which comes from regex. It allows you to search by using simple regular expressions. This is an advanced topic and we'll go deeper into it later in the course. For the moment, you should know that a regular expression or a regex is a way of defining complex search patterns. Let me show you one example. Locate -b -r caret shadow \dot and between square brackets 0 -9. This is a regex or a regular expression. I'm searching for all the files and directories whose base name start with the shadow string, then the dot sign, and any digit between 0 and 9. Any other characters can follow. And these are the files. At the end, I want to tell you a few words about another small command called which. The which command locates a command and returns the absolute path of the executable that is called when the command is run. It does this by searching the path for executable files. This can be useful in finding the location of an executable command when you intend to create a shortcut or run it using its absolute path. For example, typing which rm displays the path to the rm command. Which ls. By default, it only displays the first matching executable, and if you want to display all matching executables, if there are more, use the -a option with the command. So which -a find. ls-l bin find. ls-ld bin. In fact, /bin is a symbolic link to /usr/bin. We'll have an entire lecture on symlinks later in this section. To search for more executables at once, all you have to do is to give the executables as arguments to the which command. So which pwd ifconfig find grep and firefox. The locate command used to search for files and directories is very fast, but has two major drawbacks. It has only a few options, and most importantly, it doesn't do real-time search of the file system, but of its own database file, which should be constantly updated. Another Linux command used to search for files is find. It's a complex command line utility that searches for files in a directory and recursively through its subdirectories as well. Using find, you can search for files by name, owner, group, type, permissions, date, and other criteria. The syntax of the find command is find, path, and criteria. Let's see some examples. I'm creating a new directory with two files, mkdir projects and touch projects report.txt, and another file in the same directory, todo.txt. This is the directory tree. And find the path, the directory. It will search in the current directory by name. So name todo.txt. And it has found the file. As anything else in Linux, the name of the file is case sensitive. Another option is iname, which is similar to name, but the match is case insensitive. So instead of name, I'll use iname, and the search will be case insensitive. If you want to specify only a part of the file name, find will search by that exact name. So find dot the current working directory minus name todo, and hasn't found anything. The name of the file is todo.txt, but I can search like this: todo and a star. It found all files whose names start with the string todo. Star asterisk here means any character, and when you use shell meta characters, it's recommended to enclose them in double quotes. So it's better to specify the searched string like this. It's better. Let's try another one. Find minus name star rep star and the closing double quote. And it found a few files. All the files contain the string rep in their file names. To find and delete a file, pass the minus delete option to find. This will delete the file with no possibility of recovering it, so be very careful. Find dot minus name todo.txt minus delete. And the file was found and deleted. If you search a location your user is not allowed to see, you'll get a permission denied error. Find /etc minus name PASSWD. In this example, I've searched for the files named PASWD in the etc directory recursively, and there are some directories whose contents are not readable by the non-privileged user that ran the command. To search in those directories as well, I need to run the command as root. Another option you can pass to find is -ls, and it will execute the ls command on each file it will find. -ls. It executed ls on both files. Let's see how to search files by type, and for that there's the -type option. I'm searching for directories in /etc. Find /etc minus type D. Minus type D means directory. In fact, I'm listing all directories from /etc and its subdirectories recursively. This is its default behavior, which is time and resource consuming. However, you can specify the depth of a directory traversal using -max depth option. -max depth 2. This command will search for directories in /etc and will go maximum 2 levels deep. Let's add another option. -perm 755. I've introduced a new option, -perm, which will search by those exact permissions. Let's see how many directories we have found. So pipe wc -l. And there are 254 directories. And if I go 3 levels deep, I'll have more directories. Now there are 343 directories. We can ignore these permission denied errors. I've already explained to you what they mean. Note that when you specify more options or search criteria, Those criteria should be true at the same time. In fact, there's a logical end between them. Let's see other useful options. To search by size, use the minus size option and the number. Find /var minus type f minus size 100k minus ls. It will search the var directory recursively for files with the size of 1 kilobytes rounded up to the next unit. I'll execute the command as root. So sudo. And there are 3 files. By the way, the size value displayed by ls seems bigger, but that is because the k suffix displays the size in units of 1024 bytes, not in units of 1000 bytes. So it's only a display issue. You can also use the plus and minus prefixes to signify greater than and less than the size of n units. I'm searching for all files that are greater than 10 megabytes. So plus 10 and m. And there are a lot of files. Or I'm searching for the files that are smaller than 10 kilobytes. Minus 10k. These are the files. They are smaller than 10 kilobytes. You can also use the size option many times in the same command. Let's find all files in /var between 5 and 10 megabytes. So plus 5m and minus size minus 10m. These are the files. They are between 5 and 10 megabytes. Let's go ahead and see how to search by time, access time, modification time, or change time. To search by timestamps recorded on the files, use the -a time, -m time, or -c time options and the number that represents the number of days. Let's find all files that were modified in the last 24 hours or a day. Find /var. By the way, a forward slash at the end doesn't matter. So minus type f minus m time 0 minus ls. These are the files modified in the last 24 hours. Maybe you wonder why I've used 0 as value for m time. That's because any fractional part is ignored. So if a file was modified 12 hours ago, in days it means 0.5 days and the fractional part is ignored. So in fact it means 0 days. Let's see another example. I'm writing 1 instead of 0. If I use -m time 1, it means files modified between 1 and 2 days ago. Another example. Find /var minus type f minus a time plus 1 ls. It will find the files that were accessed at least 2 days ago. Plus 1 means greater than 1 and 2 is the next number greater than 1. So the file was accessed at least 2 days ago. If you want to search by minute instead of day, use the -a-min, m-min, or c-min options. For example, the next command will find the files that were modified in the last hour. And I'm searching in var. Minus type f, minus m-min, minus 60. So the modification time is less than 60 minutes. These are the files. I'm running the command as root. They were modified in the last hour. Let's see other search options. To search by owner, use the -user option, and to search by group, use the -group option. I'm searching in /var directory for files that belong to the GDM user. -user, GDM, and -ls. I'll run all of these commands as root. These are the files that belong to this user. And to negate an option, use -not before the option. For example, let's see all files that do not belong to the root group. Root is both a user and a group in Linux. The only user that belongs to the root group is root. I'm searching in /etc. I'm searching for files -not -group root. These are the files that do not belong to the root group. Sometimes you want to operate or execute a command on the files that are found. This is really useful. There's the -exec option that does that. Exec comes from execute. Let's see how it works. I want to see the contents of the files in the /etc directory that were modified in the last 24 hours. There are two steps. First, I'll find those files. Find /etc -typef -mtime 0. Okay, I always forget to run the commands as root. These are the files modified on the last day. The second step is to add the -exec option and the shell command I want to execute on each found file. I'll write the entire command and then I'll explain it to you in detail. So -exec cat, a pair of curly braces, a white space, / semicolon. This command will run cat on each file found by find. The cat command requires as argument the file to display. I do not know what name to write, and I'm writing a pair of curly braces. In this construction, the pair of curly braces will expand to the file found by the find command. The command after -exec ends when / semicolon appears. That's always there at the end. It's the syntax of this construction. I have displayed the contents of all of those files. Let's do another example. I want to backup or make a copy of all configuration files from /etc that were modified in the last week. As root, I'm creating a new directory called backup in /root. mkdir /root backup. And sudo find /etc -mtime 7 -typef -exec and the command cp the file to copy, and I write a pair of curly braces, and the destination root backup space / semicolon. The files were copied. Sudo ls -l /root backup. Okay, there's no file because I should have written -7, not 7. -7 means in the last 7 days. So in the last week. And 7 means exactly 7 days. So like this. Okay, there are a lot of files. All of these files were modified in the last week. Let me explain to you what happens here. For each file found by the find command, the cp command is executed. cp requires more arguments, at least 2, a source and a destination. The source will be the file found by find, or the pair of curly braces, and the destination the backup directory. So the braces are in the place where the file should be. Note that there's also the -OK option, which does the same as -exec, but interactively, as it asks the user first. If the user agrees, it runs the command that follows. Otherwise, it just returns false. So instead of -exec, I'm writing -OK, and it's asking for every file if it copies the file or not. This can be very useful if you run a potentially dangerous command and want to see exactly on which file the command will operate. That's all. In this lecture, I'll show you how to search for a string pattern in a text file. This is especially useful because the Linux configuration and log files are of type text and is common to search for a specific option, message or error. We'll talk about the grep command. Grep is one of the most useful Linux commands, even though it was created by Ken Thompson, one of the pioneers of computer science, as a private utility more than 45 years ago. The grep command searches in a text file or output of another command for a pattern referenced to as a regular expression and prints out all lines that contain the pattern. To search for a pattern in a file, you write grep, optionally some desired options, the pattern to search for, and the name of the file as a correct absolute or relative path. I'm searching in the configuration file of the SSH client for the string user. Grep, the string, the pattern, and the file, etc ssh_config. And it displayed all the lines that contain the string user. There are 2 lines. If the pattern contains spaces, you should enclose it in quotes, like grep, and between double quotes, let's say command line, and the file, the same file. And it found the lines that contain the pattern. To ignore the letter case, use the -i option. Grep SSH written in capitals and the file. And it didn't find the thing. Now I'm gonna search it by ignoring the case. So I'm adding the -i option. -i comes from insensitive. And it found a lot of lines. To print the line numbers on which the pattern was found, add the -n option. So -n. And it printed out the line number as well. Of course, you can group multiple options like this. It's the same. To search for whole words, use the W option. Like say grep, body, etc, password. And you see that grep searches for any sequence of characters, not only whole words. And it found the line that contains the string nobody. Now I'm adding the -w option. And it searched for whole words and didn't find a thing. To invert the sense of matching, so to select non-matching lines, use the -v option. V comes from inverse. So grep kernel /var log dmessage. It found a lot of lines that contain the string kernel. And now I'll invert the match. And it found all the lines that do not contain the string kernel. If you want to search for a string in a binary file as if it were a text file, use the -a option. Grep root /var log auth.log. And it says binary file, the name of the file, matches. This is in fact a data file, a special kind of text file. To search for a string in such a file, I have to add the -a option. And it found all the lines that contain the string root. If you want to search for a string in a directory, it will return an error. I'm searching for the loopback interface IP address in /etc. So grep the IP address of the loopback interface 127.0.0.1 and /etc, the directory. And it says /etc is a directory. What I can do is tell grep to go recursively in /etc and search for the pattern in every text file in that directory and all its subdirectories. I'll use the -R option. And it displayed all files that contain that string, which is the loopback interface IP address. Of course, grep doesn't have the permissions to read all the files, but I can run the command as root. By the way, if you want to suppress error messages about non-existing or unreadable files, add the -S option, like this. If you just want to see the number of the matches, use the -C option. I'm searching for the string error in a log file. So grep -C error, the pattern I'm searching for, and the file. varlog syslog. And it found 9 matches. So there are 9 lines that contain the string error. Of course, I could get the same result by using a pipe and the wc-l command. So grep error, the file, these are the lines, and I'll pipe the output to wc-l. Now there are 10 lines. A new line was written to that file. The grep command can be used to search in the output of another command as well. In the next example, I'll display the kernel ring buffer using the dmessage command and then search for possible error messages. Dmessage. This is the kernel ring buffer. It's printing out the kernel ring buffer. These are kernel logs in the RAM, most of them produced by the device drivers. So I'm filtering the lines that contain the string error. Dmessage, pipe, grep, and error. And there's a single line. If you want to see a context, and that means a few lines before and after the match, I can run grep -A, let's say 3, and -B 4. It printed out 4 lines before the match and 3 lines after it. This is what the -A and -B options do. You can also use -C from context and the number, and it will print out the same number of lines before and after the match. I want to see 3 lines before and after the match. So -C 3. 3 lines before and 3 lines after. Another common example is to check what program is listening on a specific port. To display all ports, run netstat with some options. Run it as root. So sudo netstat -tupan, and it has displayed all open ports. And to check if there's something that's listening on port 53, filter the output using grep, like this. Pipe grep 53. And there are some processes that listen on that port. Let's check if port 80 is open. And there's no process listening on port 80. Let's see the last example. ls-r and f /etc. I'm listing the etc directory recursively using the -F option, which adds a character at the end of the file depending on its type. This is the output. This is an executable file. This is a symlink, and these are directories. The output will be piped to grep which will exclude lines that contain a /. These are the directories. So pipe grep /. And -v to inverse the match. I want to exclude directories. There's no directory in the output. Then I'll exclude the empty lines. To do that, I'll use something special called the regular expression. So pipe grep -v, I'm excluding the empty lines. And now the regex for an empty line. Caret and $. Caret means the beginning of the line and $, means the end of the line. So in fact, I'm excluding the lines that have a character between the beginning and the end. No empty lines. Let's see how many they are. I'll pipe the output to wc-l. And there's this number. I can ignore those permission denied errors, or I can run the command as root. And finally, to sort the files by name, I run the sort command on the output. Pipe sort -r. -r will do a reverse sorting without wc-l, like this. And the output was sorted by name in reverse alphabetical order. To see it better, I can pipe everything to less. Without the -r option, it will sort the output in ascending alphabetical order. All files that start in A, then the files that start in B, C, and so on. And I can redirect the entire output to a file as well. See how I'm using multiple different commands and pipes to get the data I want. That's all. Take your time to deeply understand how grep works. It's one of the most useful Linux commands. The grep command searches for strings in text files. However, not only text files contain ASCII characters. Binary files such as executables may contain strings in human-readable text. In the compilation process, ASCII characters are embedded into the binary files, and sometimes when an application is deployed, some ASCII text is packed into the binary file by the developer. This contains useful information about the binary, like a short help or copyright information. There are also binary files used by different applications that embed sensitive information as credentials. The strings command extracts printable characters from binary files. It prints out character sequences that are at least 4 characters long. Let's see the printable characters from the ls command. First, I want to see its path, which ls, and strings /usr/bin ls. These are the ASCII characters embedded into ls. I'll use pipe and less to navigate through the output. So pipe less. And I'm searching for the string help. I'm pressing N to see the next occurrence. Okay, and I found the help of the command embedded into the command itself. I could also print out ASCII characters from the device file that represents a disk partition. Let's see the partition that is mounted on the root directory. This is the partition. It's /dev/sda5. And I run the command as root, sudo strings -a and the file. I'm printing all characters on the partition using the low-level device file. It's printing all ASCII characters. -A option scans the whole file, which is in most cases the default behavior. I'm interrupting it by pressing Ctrl and C. And the last example, which I find interesting, is to search directly into the machine physical memory, ls-l/dev mem. This is a character device file that is an image of the main memory of the computer, and strings/dev mem, pipeless. I've got a permission denied error because only root can search into the computer's memory. I'm using sudo before the command's name. These are the printable characters in the physical memory. It's the computer's memory. Interesting, isn't it? There are other options available, and you can find them in the man page. In this video, we'll cover different ways of comparing files' contents. This is especially useful when you want to compare either the output of the same command at different moments or the differences between a backup configuration file and the one currently used by the system. Let's take a look at the first example. I'm redirecting the output of the ifconfig command to two files at different moments. So ifconfig greater than, so command redirection, A. I'm generating some network traffic, ping 8.8.8.8. I'm stopping it by pressing Ctrl and C, and I'm redirecting the output of the same command to another file called B. A and B were created in the current working directory. The files contain the output of the command, but also the differences between the runs. To see if there was any difference between the two runs of the command, I can compare the file's contents. If you only want to know if there is a difference, run the cmp command, so cmp A and B. cmp compares the files byte by byte and displays the location of the first mismatch. It doesn't say how the files differ, and if they are identical, no message is displayed. A is equal to A. I'm copying the ls command to the current directory. So cp usr bin ls and dot, the current working directory. This is the ls binary in the current directory. And I want to see if it's identical to the original one. cmp usr bin ls and ./ls, ls from the current working directory. It's the same with simply writing ls. It's the same. And they're identical. Nothing was displayed. So note that cmp can be used to compare binary files as well. By the way, another way to compare two binary files to see if they are identical is to calculate and compare their hash. The hash is a unique cryptographic ID for each file. Let's calculate the hashes of the ls files using SHA-256. So SHA-256 sum, this is the name of the command, and the path to the file. So usr bin ls and ls in the current working directory. And they have the same hash, meaning they are identical. If even a single bit were different, the hashes would be different. Now, I'm changing the copied file. I'm appending something at the end. For example, echo A greater than ls. Let's see if the binaries are still identical. cmp usr bin ls and ls in the current working directory. And they are not identical anymore. They differ on the first line. And the hashes? the hashes aren't identical either. Now, if you want to go deeper and see exactly how they differ, you should run the diff command. It's used only for text files. So diff A and B. Diff stands for difference and is used to display the differences in the files by comparing them line by line. So, from its output, it can be seen that the lines that differ are those related to the received and transmitted packets. This is normal because there was network traffic between the runs of the ifconfig command. I've run the ping command. Let's take another look of the output of the diff command. Let me explain to you how to interpret the output of the diff command in another example. First, I'll install the OpenSSH server or daemon because we'll need it anyway later in the course. So sudo apt install SSH. And it's installing the OpenSSH server. It's done. I'm copying the configuration file of the SSH daemon in the current working directory cpetc ssh /d_config and the destination the current directory. This is the configuration file of the daemon that will be copied in the current directory. I'm opening the file and changing the port option. Of course, I'm opening the copy. And instead of port 22, I'm writing port 29. And I'm saving the file. If you don't know how to use VI, edit the file using gedit, the graphical editor available on Ubuntu. This one. Just go to etc SSH and open the sshd_config file. This is the file. However, we'll go really deep into the VI editor in the next lectures. And I'm running the diff command on the files. Diff, the original file, etc ssh sshd_config, and the file in my current working directory, the file I've modified. Let's take a closer look at the output. It's showing us the line that differs and the line number. In this example, it's line 15. The character C after 15 indicates that we have to change or replace the line 15 in the first file by the line 15 in the second file to make them identical. Two other meaningful characters are A and D, where A means add or append and D means delete. Lines preceded by a less than sign are lines from the first file, and the lines preceded by a greater than sign are lines from the second file. In fact, the diff command helps us make the files identical and indicates exactly what should be done. This is used by the patch command to patch a program that has a bug. Let me tell you a few words about it. Suppose a new bug, which is a programming error, was discovered. The solution to make things right is the developer to change the source code. Instead of releasing an entire program, the developer releases only a patch, which is in fact a file that contains the differences between the file that has the bug and the file where the bug was solved. This file, and I mean the patch, was generated by the diff command after calculating the differences between the two source files. You can then apply the patch to the file that contains the bug using the patch tool. The patch file indicates how the file should be changed so that it becomes identical to the other file, the right one. Other useful options of the diff command are capital B to ignore blank lines, W to ignore white spaces, and I to ignore case differences in file contents, and C for a more detailed comparison. And the last option, which is Y, if we want to display the entire file's contents on two columns side by side, indicating the differences. So diff -Y and the files. Here's the difference. Of course, a pipe to the less command would be much better. To configure or change anything on Linux, you need to edit a specific configuration file. To write or edit files, you need a text editor. There are text editors that work in graphical mode and text editors that work in the terminal without a graphical interface. Since most of the administration work is done in the terminal, you need to learn how to use the text editor that doesn't require a graphical interface. They are called CLI or Command Line Interface Editors. There are a lot of such editors, and among them we can mention VI, Vim, Nano, Pico, or Emacs. In this course, we are going to use a text editor called Vim, which is, by the way, the most used editor and the default one for many Linux distributions. Vim stands for VI Improved, as Vim is based on VI, and VI is the original text editor on Unix released more than 40 years ago. Everything in VI is available in Vim, plus some extra features. If VI is always available on any flavor of Linux or Unix, depending on your distribution, Vim should be installed or not. To install or update Vim on Ubuntu, I'm running sudo apt install vim. And it's installing it. And on CentOS, sudo dnf install vim. Vim is a very powerful text editor, and it offers extensive text editing options. However, in this introduction, we are going to focus on exploring some of the more basic functions and commands, the ones that are required for basic file editing. Keep in mind that Vim is not so easy at first sight, but once you learn how to use it, you'll love it. If you try to open a file using VI, like VI and the file name, it just opens it in Vim because VI is an alias or a symlink to Vim, both on Ubuntu and on CentOS. In this example, the file was opened with Vim. I'm exiting the file, typing :WQ. As you notice, VI is an alias to Vim. Let's get started with Vim. To use Vim on a file, you type in Vim and the name of the file using a correct absolute or relative path. If the file already exists, Vim will open it for editing, but if it doesn't exist, then Vim will create the file. I'll make a copy of an existing file to show you the basics of Vim. I'm copying the SSH server configuration file from /etc/ssh to the current directory. So cp etc sshd _config and the destination the current directory. And I'm opening it with Vim and the path to the file. Vim is a model editor, and that means it has three basic modes of operation: command, insert, and last line modes. When you open a file in Vim, you are in the command mode. In this mode, characters you type get interpreted as commands. Like X will delete the character currently under the cursor, or R will replace the character under the cursor. I'm pressing R and 6. And it replaced 1 with 6. To get back to this mode from any other mode, just press ESC 1 or more times. I'll tell you a secret. When you are in a mode and get stuck, press a few times the escape key and it will take you to the command mode. To start writing text as in a normal text editor, you need to enter into another mode called Insert. To enter into Insert mode, from command mode, press lowercase I and it will insert the text before the cursor until you press ESC. So, I'm pressing I, I'm in the insert mode, and I can write like in any other text editor, until I press ESC. Remember that when you hit ESC, it enters the command mode. Now I'm in the command mode because I've pressed ESC. If I press the uppercase I, it will start inserting the text at the beginning of the current line, until ESC is hit. I'm in the command mode again. If I press A, the lowercase a, Vim will append the text after the cursor, until ESC is hit. An uppercase A will make it append the text to the end of the current line. And the last two keys are lowercase o to write the text on a new line below the current line, and uppercase O to write on a new line above the current line. So in a nutshell, to enter insert mode from command mode, type I, A, and O, both lower and uppercase. The third Vim mode is known as Vim last line mode. You can only get to the last line mode from command mode, and you get into last line by pressing the colon key like this. I'm in the last line mode. After pressing this key, you'll see a colon character appearing at the beginning of the last line of your Vim editor window, and the cursor will be moved to that position. From Vim last line mode, you can do all sorts of things like saving the file, quitting the file without saving it, and so on. Let's quit Vim without saving the file. I'm writing Q and an exclamation mark, and I'm hitting enter. I quit without saving. I'm opening the file again and making some changes. I'm typing O to write on the next line. When I'm done, I'm pressing ESC to go to the command mode again. From the command mode, I'm pressing colon and I'm in the last line mode. To save the file without closing it, I write W and an exclamation mark. And I'm hitting enter. The file was saved. If you want to save the file and then close it, in the last line mode, type WQ and an exclamation mark. I'm opening it again. One of my preferred shortcuts or commands while in the command mode is to save and quit the file quickly and easily by typing Shift and double Z. So I'm pressing Shift and Z 2 times. That was the basics of Vim. You can now perform basic file editing. To go deeper into Vim or just practice it, run Vim tutor and Vim will open a tutorial file. You can freely work on it because it's a copy. Next time you'll run Vim tutor, it will open the same original file without any of the changes you have done. I'm making some changes. And I'm saving and exiting the file. I'm running Vim tutor again. And I'm seeing the original file. In the next lecture, we'll dive deeper into it and I'll show you many other useful Vim features. See you in a second. Let's dive deeper into Vim. I'm opening a text file for editing using Vim. You can run a shell command from within your Vim editor session like this. Go to the Vim last line mode by typing a colon, an exclamation mark, and then the shell command. Say ls, and the command was run. One more time. Colon, a question mark, and the command ifconfig. To search for a string or a pattern in the command mode, type a / and the string you search for, and then hit enter. SSH and enter. Any matches in the current window will be highlighted. You can then navigate between matches with N, I'm hitting N, or Shift N. N will go to the next match, and Shift N or uppercase N will go to the prior match. This works exactly the same as for the less command. When you search by using a / followed by the searched term, it searches forward. But if you are, for example, at the end of the file and want to search backwards, then you type a question mark instead of an exclamation mark and the searched term. I'm going to the end of the file by typing capital G. I'm at the end. And I'm writing an exclamation mark and the searched term, for example, port. And it found the string. Another quick way to find the next occurrence of the word under cursor is to press an asterisk. The word under the cursor is yes, and I'm pressing asterisk, a star. And it found the next occurrence. And the next one, I'm pressing asterisk. The previous occurrence of the word under the cursor is found with a hash sign. The word under the cursor is no, and I'm pressing hash. And it found the previous occurrence. It's searching backwards. I'm pressing the hash sign multiple times. To search for a pattern and replace all occurrences, in the last line mode, write. I'm in the last line mode and I'm writing %s, lowercase s, the searched term, for example, no, this is just an example, the term or the string I want to replace with, for example, XXX, and G. I'm replacing all occurrences of no to XXX. Now, I think that was a mistake and I can undo till the last saved version of the document by typing E and an exclamation mark in the last line mode. So colon, E and an exclamation mark. And I'm hitting enter. Note that it didn't undo only your last operation, but up till the moment you've last saved the file. To undo the last operation only, in command mode, type U. This is equivalent to Ctrl and Z in a graphical text editor. And to redo the previous operation, type Ctrl and R. Let's talk about cutting, copying, and pasting a text. If you want to cut a line, press D 2 times. So double D. The line was not simply deleted, but copied to the clipboard. To paste it somewhere else in the document, move the cursor to that position and press P. I'm pressing P. The line was pasted there. To cut more than one line, type the number and then DD, so double D. For example, I'm cutting 10 lines below the cursor and I'm writing 10 and double D. And the lines were cut. This could be a simple deletion, or I could paste them in another part of the document. I'm moving to that position and pressing P. Okay, let's move on and see how to copy and paste the text. The first step is to position the cursor where you want to begin copying. Press lowercase v to select characters, uppercase V to select whole lines, or Ctrl and V to select rectangular blocks. Use the arrow keys to define the selection. For example, I'm pressing the capital V, the line was selected, and now I'm using the arrow keys to define the selection. I'm going down. After selecting the text, press Y. I'm pressing Y. Y stands for yank in Vim, which in other editors is usually called copy. Now move to where you like to paste. For example, at the end. Press capital P to paste before the cursor, or small p to paste after. I'm pressing lowercase p. And the text was pasted after the cursor. In the last line mode, you can run many Vim configuration commands, such as for example the command that tells Vim to show line numbers in your current editor window. So set NU from numbers. And it has displayed the line numbers. If you don't want to display the line number, which is useful when you want to copy and paste from Vim into another editor and don't want to take the line number as well, run set no NU. So set no NU. It comes from no numbers. Okay. Another useful feature is syntax highlighting, which is nothing but a feature of Vim that displays a text, especially a source code, in different colors and fonts. To enable or disable syntax colors in last line mode, run syntax on to enable syntax highlighting, respectively syntax off to disable it. I'm writing syntax off. And syntax highlighting was disabled. Now I'm enabling it. Syntax on. Note that these changes are not permanent. If I exit Vim and then open it again, I'll notice that neither the line numbers nor the syntax highlighting were saved. I'm exiting Vim and saving the file. So W, Q, and I'm hitting enter. I'm opening the file again, and I don't see the line numbers. To make the changes permanent, in the user's home directory, create or edit a file called .vimrc. This is a hidden file because it starts with a dot. And in that file, write all commands you normally write in last line mode. So I'm exiting Vim and I'm opening a file in user's home directory called .vimrc. And in this file, I'll write the Vim commands. For example, set NU and syntax on. I'm saving and exiting the file. Now the changes are permanent because each time Vim is opened, it will run the commands in that file. See that? The line numbers are there. Let me show you a few more useful shortcuts. If you want to move to a specific line, in last line mode, type the line number and press enter. For example, I'm moving to line 100. This is useful when you get an error in a shell script or configuration file and it says that the error is on a specific line, like on line 250, and you want to move there to see what's all about. To move to the end of the file, type capital G. Okay, I'm at the end. To move to the beginning of the file, type double G, lowercase g, or move to the first line as I've already shown you. I'm typing G 2 times. I'm at the beginning. Or :1 and I'm hitting enter. It's the same. Let's see how to work with multiple files at once. This is useful when you want to copy and paste between files or to visually compare the file contents. You can open more files like this, vim and the file names. I'm quickly creating two files using a redirection, ifconfig greater than a and who minus a greater than and b. So I've redirected the output of ifconfig to a and the output of who minus a to b. This is a and this is b. And I'm opening both files, so vim a and b. It's displaying the first file, but I can move to the next one by typing n or next in the last line mode. So colon n and I'm hitting enter. This is the next file. To access the previous file, type prev or capital N in the last line mode. So colon prev and I'm hitting enter. This is the previous file. Another way to work with multiple files at the same time is to use the -o option, which will split the window and open a window for each file. This is known as stacked windows. I'm exiting this session of Vim. And I'm writing vim -o, a and b. You can move between windows by pressing Ctrl and W. I'm in the second file, and now I'm in the first one. This is a convenient way to copy and paste or to do other operations on both files. For example, I'm pressing Shift and V. I have selected the line. Now I'm pressing Y. I've copied to the clipboard. Ctrl and W to move to the next window. And P to paste the line. Okay, sometimes it's useful to view two files side by side and see the differences between them. This is especially useful when you change some configuration options of a service, and after a while you want to compare the file with a baseline, with the original one. I'm exiting Vim. Let's take a look at an example. I'm copying the configuration file of the SSH server again in the current working directory to have the original file. And I'll do some changes. I'm opening the file and change port 22 to port 29. I'm saving the file. Now I want to open both files to see the changes. To do that, I'll use the -d option, vim -d, the original file, and the copy. You see both files opened in stacked windows, and the lines that are different are highlighted. Now you can move between files by using Ctrl and W. I'm exiting. There's also a wrapper called vimdiff that calls Vim with the required options. So vimdiff and the files. It's the same as running vim -d. I'm exiting without saving. One last thing. If you exit Vim without properly closing it, so without using a command or a shortcut, like closing the terminal or pressing Ctrl and Z, next time when you open the same file, you'll be presented with a message. I'm opening a file, this one. And instead of exiting using a shortcut, I'm pressing Ctrl and Z. This isn't a Vim shortcut. Or I can close the terminal, the entire terminal. I'm pressing Ctrl and Z. Now I want to open the file again. And I'm presented with this message. What I can do, I can try to recover the file by pressing R and then saving it normally, or I can simply delete the swap file that was created. This one. So I'm typing enter, I'm exiting, and I'm removing the swap file. This one. And next time I can open the file normally.